Welcome to the stream, guys. Looks like we're connected on all of our networks here. I was trying to wait until we had a green signal, but I'm sure it'll rectify itself. I am very excited tonight. We've got a really awesome show for you. So let's go ahead and just go right into it. And let's get our guest in here. Professor Phil, thank you so much for joining us tonight. Glad to have you.
Thank you. My pleasure.
So I saw you on the Ranty Roundtable, and you were talking to Sleeping Warrior, and man, did that conversation go for a loop. And I'd love to have you kind of talk about how that all happened, and then I know you've got a couple things you want to show us, and I'm excited to see it. So, and also if you want to introduce yourself, I shouldn't get ahead, so please do if you will.
Look, in a nutshell, I guess my background is in chemistry and physics and mathematics, and I work at in India quite a bit in a number of fields, mainly in the space industry. And when I'm not doing that, I'm lecturing in physics and chemistry. That's it in a nutshell. I guess the reason that I got involved in the first place was I noticed on YouTube that this flat Earth thing was growing considerably, and I thought I'd just like to help them out because I could see that they weren't going anywhere, and of course without some recognition from the academic. So I thought I'd get on the show and help them out and show them what they would need to do to be able to get some respect instead of always being mocked.
Yeah, you did a great job, because when you talked to a Sleeping Warrior, I could, tell you really cared to show them a little bit about the scientific process and how they could be taken seriously more than they are. And it went awry, that's for sure. You started off telling him we're not here to attack each other, but when he started talking, the first thing he did was attack you, and that literally blew me off my chair.
Are we having some technical difficulties?
Oh, can you hear me okay? Did you lose me? Check. Can you still hear me, Phil? Looks like Skype's going in and out on us. Okay, we'll give him a second. Let me go ahead and stop sharing my screen. That might help. Let me know if you can hear me now, Professor. Let me go ahead and recall him. Let me bring him back in. Okay, here we go. Get him reconnected. Bear with us, guys. I'm going to download this, edit it, and re-upload it too. And he's going to take your questions, so make sure you be ready for that too. Have them prepared.
Hey, what happened?
Connection issues, I'm sure. Skype's not the most reliable thing.
Okay, I'll tell you what, let me switch to a different internet just to be sure, okay? Do you mind?
All right. No, go ahead. That'd be great.
I'm just going to, I've actually got I've got two modes of internet, and one of them comes from satellites, would you believe it? So I think I'll go with the satellite one.
All right, great.
It's ironic, isn't it? Here we are.
Definitely. And that reminded me, I needed to connect to my second internet too, just in case we disconnect. So, yep. If we have any issues like that, we'll just reconnect real fast. So.
No problems at all. Yeah, I'll just set up the satellite one now.
Okay.
Yep.
And while you do that, what I was trying to say was that you were being so kind and helping these guys so much in that conversation. But the first thing that Sleeping Warrior did was attack you when he got to talk.
Right. Yeah,
it blew me out of my chair. It really did. How did you take that? I saw you were trying to handle it in the most professional way you could, but these guys, it was insulting to watch from this side. I couldn't believe he didn't see it. Okay, hold on. We're coming back.
Are we back? No,
yep,
we're back again.
We're back. Yep.
Okay. Yep. All right. Okay. No, it's good. This is a better connection.
Great.
Okay. Yeah, yes. So how did I take it? Well, put it this way. I was hoping for the best. I thought, hang on a second. This guy knows that he's talking to a professor. He knows he's talking to an academic. And he'll probably be respectful. That was my initial thought, but obviously I was just so far wrong.
Yeah, I with everything you showed, there was no rebuttal for him, in my opinion. If he was to address what you put out, I mean, how would he even start? So I think that was why he did it. I think he knew he was bested and went with the backup plan of fighting with you, trying to fight, you know.
There was one instance where he actually put something up on the screen, which I thought, hang on a second. He was trying to show us that the sun need not speed up as it goes around the flat Earth, because this is one of their major problems. And I'll show this in a series of slides that I have, so people can see exactly what I mean. And he did come up with something, and I thought, I've noticed in the flat Earth industry where they just simply say the sun moves from Cancer and then works its way to the equator and then works its way south to Capricorn. And I thought that has to be complete nonsense. And then he came up with something a little bit different, and I thought, well, you know, to be fair, I haven't looked at that, you know. So I have since, and it's still just as much nonsense, actually.
Yeah, as expected, really. So of course, the first thing I thought after I saw you make that great presentation was that I wanted to hopefully have you go into that a little bit here, so we can go into that.
Sure.
Because it's just excellent. And I've been thinking, the thing that really struck me was I was having those same thoughts this entire time. My main thought is, if people like Nathan Oakley and Sleeping Warrior are going to take this seriously, they wouldn't just try to win debates like they do and argue semantics, and they would try to sit down and get across those basic hurdles that they're facing. So if you want to pull up that presentation and go into it a little bit, it's just excellent.
Well, before I do that, I want to give Ranty Flat Earth some credit.
Yeah.
Okay. And you know, and I know they rib him a bit for being the flat earther who disproves flat Earth all the time. And there's probably some truth in that, and this would be a case in point where he actually did use his channel for that. However, I have to give him credit, and that is, he has had people on there who are not flat earthers who do try to explain things. However, he pits them against people like Sleeping Warrior, and their message is usually lost in the semantics.
Yes.
Sleeping Warrior has a vested interest in him, and others like him have a vested interest in making sure that they keep the discourse to the semantics. In other words, they don't argue the actual points that they need to argue. Anyway, so I'll go into the slides, and I'll bring this up, and we'll go through this share thing again.
Yeah, bottom right corner, those three dots, and you'll see it'll say share screen there. Don't worry about sharing audio, because it'll lag our connection a little. So.
Okay, all right. Okay, so okay, I'm not sure if I did this right. Yeah. Okay, so I've got the three dots down.
Yep.
Okay, can you see my screen now? Can you?
Definitely, yeah.
Okay, so I'm going to minimize that, and then I'm going to start the slideshow from the beginning.
Okay.
There we go, slideshow, and from the beginning. Okay, so you can see that I'm just going to remove this up the top there. Okay, so observations to be addressed on any flat Earth model, and this is exactly what I was trying to do. I was trying to actually help them. Okay, and this is in order to be taken seriously by scientists and the world. If they can't be taken seriously, there won't be any money in it. And in order for them to advance their cause, it needs some substantial funding. I don't mean $2,000 or $3,000 to pay for petrol to go around and harass people on the street. I'm talking about millions of dollars that might involve putting a rocket into space, and that might involve some very, very serious testing. All of those things cost a lot of money, and if they want to be taken seriously, there are people who will take it seriously, provided they can answer the basic questions, and provided that they're genuine about answering questions. So I'll move on to the next one. Let's see. Okay, over here, let's look at this one over here. I mean, seriously, this just about kills it straight away.
Oh
Well,
yeah.
doesn't let's say it doesn't kill flat Earth. It kills this model of it. Okay, so in science, someone would come up with an idea and say, look, I've got a hypothesis that the Earth is flat, and people say, okay, what are you going to do? What sort of experimentation can you put in place that would describe that? And how would you correlate your hypothesis about the world being flat with observations that we see on the ground that we make? So you need to come up with an explanation like this. So in this case, we've got exactly half the Earth in daylight and half in darkness. This is an indisputable fact. Anybody can check, anybody can ring up a friend in another country. The world is a very, very small place communication-wise. So let's have a look at the one that's on the left. Those arrows that you see there, those lines, are the same size. So if you have a look at the ones that are in the light, as it were, so the sun is shining half in some sort of semicircular way, which you'd expect that to be the case if this was reality. But have a look at the one in the middle. How do the people in the dark not see the sun? In other words, where is the magic lampshade? Now, not only does this magic lampshade have to prevent those people that are in the darkness from seeing the sun, this now has to move around because that sunlight has to move around in a circular way. In fact, it's got to go around once every 24 hours. Mm-hmm. And the people in the dark must be prevented from seeing the sun. Straight away, you can see that this model cannot work. Now, if you were a genuine flat earther, you'd have a look at this and you would say, that's true. This isn't working. I'm going to see if I can find another model. So you look across and you see this other model over here and say, right, the sun moves around like a torchlight. Well, okay, the problem with that is it's a nice little idea. And the way it moves through the season, that's also a nice little idea, but it's got some basic problems. First of all, it doesn't shine up half of the Earth all at once. And that's its basic problem. So the people who came up with the one on the left-hand side knew that shining the sun shining on half the Earth was an issue that they would have had to deal with. So they came up with this one. But the trouble with some of the theories, and I shouldn't call them theories, some of the hypotheses that come from flat Earth is they don't actually follow it through. So they'll come up with something that looks like an explanation and not follow it through to say, well, I need to compare that with other observations. What they don't seem to understand is they need a coherent model. A model that can explain all of the things at once. It can't just explain some things and not others. So,
let me ask you a question before you move on from that slide. Just a really quick one. Is there anything that could explain their model? Because I've been trying to look at it from their perspective, and I can't find one thing that could explain it.
Look, there's some things that haven't been looked into carefully. So this particular problem, that is where half the Earth is shining from a source that is clearly spherical. Mm-hmm. Well, let's say, for instance, we gave them the idea that they had this dome, all right, which is an interesting thing. You can have a look at that because it has many, many more problems to deal with. But let's just say that the dome solved all the other issues. It's quite possible that some way that the light shining on a dome from outside of the dome, so forget about being inside, that wouldn't work.
Oh, I see what you're saying.
Outside the dome, then that is possible because we're looking at refraction through some sort of I don't know what the dome's made out of, glass, water, whatever whatever hypothesis you come up with. But it's possible that you could conceive that the light could be made to appear to be shining up half of this Earth, the flat Earth, even though the actual source is spherical. Now, that needs to be looked at. So if I was a flat earther, I would have put everything I got into having a look at that. But then you'd have to address the issues that a dome would pose, like, for instance, Dalton's gas laws, where you'd expect everything, all the gases under the dome, to eventually heat up and become homogeneous, which it isn't. We have a gradient. Okay.
Thank you. I needed to hear at least something that there is a possibility out there they could at least try to argue.
Yeah,
so
there always is.
Okay.
It's just dismissing things out of hand is no different to what they do, actually.
Yeah.
To what flat Earth people do. So you give them and say, look, you know something? 3 Saturdays ago, I was involved in a mission where a spaceship crashed on the moon. And it's an unfortunate thing, because that was about 11 years of work and hundreds of millions of dollars. And then just out of hand, somebody who calls himself a flat earther just completely dismisses that, like as if it never happened. And here we are. I'm flying to India in a few days' time. We'll be working on this problem, and there's people saying it doesn't happen. Well, hang on a second. There's thousands of people involved in this.
Mm-hmm.
Look, have your flat Earth model if you like, but you can't deny this happened. It did. It's as simple as that.
Exactly.
Anyway,
yeah.
Now, but the other option that hasn't been looked at with respect to how do you get a that half sun, and that is the possibility that there could be 2 suns. So I haven't heard them argue that, but they don't give a lot of thought to their model anyway, so they probably haven't thought about it.
Mm-hmm.
Now, let's have a look at this. This is interesting, because I have to give credit to the people who came up with this. Because, let's face it, they did give this one a little bit of thought. So in other words, how do the seasons work? And it's actually quite cute, the way this works. So what they're saying is that the sun moves from one tropic to the other, which has a minor resemblance with the tilt, if you like,
mm-hmm.
of the way that works, because that's kind of what happens in the tilt. Although it mainly focuses around the equator. They haven't mentioned that, though. But I kind of like the thought that went into this, even though it's wrong. And basically it's wrong because the sun's speed would need to make drastic changes from its position in Cancer to its position in Capricorn. And those things are, in fact, it's counterintuitive, because the sun over Capricorn, for instance, well, even over Cancer, can last 10, 12, 14 hours a day. You see the daylight goes for 14 hours a day. Well, this model clearly can't deal with that. And let's have a look at, this is a picture. This is Antarctica, by the way. This is 2 o'clock in the morning. Okay, it's a cloudy day, but clearly the sun is shining, and it's predictable around about 20 degrees off the horizon. This is yours truly around about 20 years old.
You got some penguins behind you, I see.
I tell you what.
Are they friendly? Are they nice? Or how do they react to people?
No, look, if they were there, if you disturb their eggs, so if you were to walk amongst them, and it was mating season or egg laying season, then you'd be in some serious trouble. but otherwise they're pretty docile creatures. They're fantastic to watch. But in amongst them, I mean, you can't really tell from this photograph, but there's sea lions and and other creatures, so they're not alone. It's quite a fascinating place where you can see that there's no snow, so this is the height of summer. But as the winter creeps in, it becomes a very, very ominous place. It's blistering cold, and you let's say, for instance, being a guy, you go outside. So I'm going to go outside and take a leak, just out there. Well, you can't because because the fluids in your body would freeze up.
Oh wow!
It would be a painful exercise.
I can imagine.
Yeah. So if you're going to have a leak, you got to do it inside the hut. Okay, you're definitely not doing it out there. On the other token, is nothing goes off. Like your loaf of bread will you can leave it outside for weeks and nothing will attack it. There are no germs practically to attack anything. So food doesn't waste. Although one of the things that we're asked to do, and that is not to leave anything behind. So that could have an effect on the environment. So they're very, very strict about what you leave behind. So even human waste has to be removed. Yeah. So yes. Now this is a place where anybody can go to. I mean, I listened to them saying, "Oh, you can't go there because someone's going to shoot you down." And what a load of nonsense! You can actually charter. There's any amount of cruises that'll take you there. There are so many expeditions that go all the time. In fact, it's getting to be quite annoying. It's that crowded because the trek to the South Pole is now like a wait in line. It's that crowd. It's like, I don't know if you've seen pictures of Everest where people wait in line to go to the peak. It's like there'll be 200 people sort of in a line waiting for your turn to be at the peak. It's getting to be a bit like that. So it's quite crowded, and if people want to go there, they can. And if you spend 1 or 2 days there, the first day you spend there, anywhere between December the 22nd and about 7th or 8th of January, you'll notice that the sun didn't set. Okay. Now, this is just so totally inconsistent with this AE model that you've got to say that if you experience this, you've got to say that that model doesn't work. Let's see if there's something else that does. You've got to be truthful about what you want to learn. It could be that you'll say, look, for now, I'm going with the spherical model because not only does it work, but I actually have nothing else to go with.
Yeah, I've always thought that myself. It's kind of a flat Earth killer that I was just watching videos of the sun and watching it rotate in the sky in the north and south, and it.
Well, I mean, often there's a couple of things people say. Well, if things actually go into space, why don't they get the camera and whip around and look around everywhere? And what they don't understand is that putting a camera on a spaceship is not an easy thing to do. That's number one. And number two, it's expensive.
Oh, yeah.
A kilo of anything in space is about $30,000 to $40,000 for 1 kilo. That's the cost of taking something into space. So if that's the kind of cost, and you're saying the only reason that we're putting this on there is so that we can show people that the Earth is spherical. Well, almost anybody involved with that would think that was ridiculous. Why are you trying to show people the Earth is spherical when everyone pretty much knows that since grade school?
Yeah.
So why would you spend $30,000 or $40,000 trying to do that? Not just that, but the application of that, the telemetry, all of that can go into it, the risks involved. It wouldn't happen. Nobody would do that because nobody needs to prove that the Earth is spherical. doesn't make any sense to people who are actually doing the work. So let's just have a look at this. Questions that they need to ask themselves. What force is applied that makes the sun move, and what keeps it moving? I mean, what is the fuel involved in this? There's some few ideas that I think I could probably kick around, but I haven't heard any from the flat Earth people. Mm-hmm. All right. Given that the sun must change its velocity on the model, what force applies to make that happen? You can't change velocity without acceleration and a force being applied in a different direction. So otherwise, it's not going to change the velocity, and certainly not going to change direction. Why are tides independent of day and night? I mean, why is that not a question that's not asked? One of the things that I hear often is water doesn't bend. Well, I see waves, and then in my lab I see the meniscus when I'm looking in a test tube.
Bubbles.
And then I see bubbles, and I see drops of water that fall out of the sky, and huge hailstones that make a dent in the car, and I'm thinking that's just absolute nonsense. But then this is the clincher in point number 7 over here. So you go to the beach and the tide is out. I mean, sometimes so far out that you could walk for miles out there. I don't advise it. Something happens and you can't come back, you'll be in some serious trouble. So, but the tide is right out. Why aren't you asking yourself, where is all the water? Where did it go? Well, surely it can't be flat because the water's gone somewhere. Did the flat Earth tilt? How about you give us an explanation for where the water's gone? The water's obviously a hump somewhere, because if you ring up your friend who's having a high tide, your friend will tell you, wow, all the water that you haven't got over there is all over here. We call it high tide. It seems to be obvious to anybody, just gives that 5 minutes of thought. No, 1 minute of thought.
Jeranism was just making this argument. He was saying that the sun or the moon push the water around, and I'm thinking to myself, like, but just like you said, independent of day and night. And
well, let's just say take what he just said and say, right, okay, the sun and the moon push the water around. Okay, so it bends. That's all I wanted to hear you say. Yeah. It bends. It's not lying flat. Once you realize that it's possible, that it's not lying flat, and that's actually quite easy to explain why it does go around the sphere. Because water is not a plasma, it's individual molecules. And each and every one of those molecules has mass. And whether you believe that gravity is a thing or not, everything that has mass has to fall. And if it falls, all of these particles are doing their level best to get as close to the center of mass as possible. Therefore, the ones at the surface must be spherical, because that is the closest that they can get to the center. If it was square or flat, the ones in the far out there would not be close to the center. That wouldn't work. Everything needs to be as close to the center as possible. So it cannot be anything but spherical. That alone should be patently obvious. Mm-hmm. Okay. If you're standing in Cape Town, South Africa, which I've spent some time there as a youngster, so I having escaped from Kenya at the time. I was born in Kenya, and having escaped from Kenya at the time of independence, we all thought that was going to be a bloodbath, and it was to a degree. My grandfather was killed.
Oh, sorry to hear it.
Oh, yeah. So that was a terrible time living through a war. And then going to South Africa, where it was like going from the frying pan into the fire. We had apartheid and other things to deal with. It was a pretty scary time. But anyway, I've lived there, and if you look if you look south from Cape Town, you can see the Southern Cross. Look up towards the south. You can see the Southern Cross. Okay, and this is nighttime. And the same person in Melbourne, that's where I live now, looks up in the sky and they see the Southern Cross. Well, so in other words, have a look at this next video, this next slide. So, 120 degrees between these two places, looking at the same Southern Cross.
Oh, yeah.
How does this not debunk this particular model of the flat Earth? I mean, that's just pretty obvious.
Have you ever heard them give one reason why for this fact? I can't think of one thing they've ever said that would.
No, and I'm happy to entertain a different model. Let's come up with something that explains these two things, that explains how you see the Southern Cross 120 degrees apart. Explain that. And they'll say, oh, well, they're not both at night. Well, this clearly shows that both those places would be at night. They'd both be in darkness. So they're both going to be able to see the Southern Cross, somewhere in the sky. I'm not saying they're going to be in the same place in the sky. One, it might be towards the east in one and towards the west in the other, but they will see the Southern Cross. Both of them will. That is impossible. They must be looking towards the same place, and of course they are. They're looking towards the South Pole.
Definitely.
Yeah. So this alone, you want to get serious? You want people like me to take you seriously? Answer this question. Come up with a model that answers this question, because I'm not going to beat around the bush. The first time you come into my office with your hypothesis about what the world is, I'm going to ask you this question. I'm sorry, but I'm not going to beat around the bush. Okay, I am going to ask you this question. So before you come into my office, don't waste my time. Come up with a solution for it. But for you to walk around the streets trying to tell people that the Earth is flat, without having the honesty of saying, look, we think the Earth is flat, and this is the model that we have here on our board. However, it has a serious problem in that if you stand anywhere, if you stand 120 degrees apart, you're going to see the Southern Cross. That would be the honest thing to tell those people on the street. Okay,
definitely.
Because but so don't hide it. Don't hide those simple facts. You can let people walk away with and make up their own minds, because they keep saying that. Oh, we're not here to convince you. We're just here to make you think. Okay, well, add this to your board because it's a fact. And then give them an opportunity to put all of your ideas about why the Earth is flat and all of the problems associated with the Earth is flat. So they've got half a chance of getting it right. Because the way you have it at the moment, you're hiding the facts, and in some cases, deliberately hiding the facts.
No, they definitely are. I just showed a video from a flat earther who was out on the street at a university handing out pamphlets and, trying to get people to do exactly that, do your own research, think a little bit. And I guarantee this isn't in his pamphlet. And I also guarantee I was looking at videos of the the way that the stars rotate. I forget what that point's called, over the pole, but there's a word for like
pole,
thing or whatever.
The pole star, yes, the Polaris.
Yeah, and then and in the north it rotates one way, and in the south it rotates the other, and it's very evident of what's going on. So, but yeah, sorry, I had to add that in.
Yeah, no, you're quite right, and in fact, if you're anywhere in Australia, you can't see it, and you've got to be asking your question: how come? Why can't you see it?
Yeah.
And the other question is, they claim that the sun just goes away. Well, why doesn't it eventually look like a star in the distance, at least? Because how can it just disappear like into the blackness, and so that you can't see it? That absolutely doesn't make sense. The issue I have with that is that for the people who are claiming that it happens, why are they not asking themselves these basic questions? Don't they care enough? Don't they care enough about what they believe? Do they just leave some of their common sense at the door and say, look, I want to believe this, so I'm only going to take it so far, and then when it becomes nonsensical, I'm going to try and pretend that this stuff doesn't happen, that somehow the light of the sun just disappears into blackness. Well, the stars are evident. Why isn't the sun? Is the sun, supposedly the stars are behind the dome. If you can see them, why can't you see the sun? This business of trying to deflect with refraction of light, diffraction of light, that's just a nonsense, And if you give it any thought and you're serious and you actually care about what you think, then I'm afraid you've got to draw the conclusion that it is nonsense.
Especially when you can raise up into the sky and watch a second sunset. You can do it in an elevator, in a tall building, or just with a drone. You can see the sunset twice. It's fascinating.
Exactly. Well, the other thing about it is this misunderstanding about what science is and what science is trying to do. Science isn't actually trying to prove anything. Okay, science is about saying, I need an explanation for this, a coherent explanation. And over the couple of thousand years, that this coherent explanation has been developed. That's the heliocentric model, which has been passed on to generation after generation, scientist after scientist, giant after giant. And when I say giant, I mean giant in their minds.
Yeah.
So people like Kepler, people like Newton, who were absolute giants, intellectually, who thought about all of these things, put this model together, and asked themselves the serious questions. Even to the point where, before Newton died, asked himself the question about what is gravity and couldn't answer it. He knew a lot about what it did. The equations were perfect. The equations are used today. So if my crew spends $600 million of ours and other people's money putting a satellite in space, using these formulas like Kepler's r cubed over t squared, $600 million, we're relying on this formula. You better believe it works. This is
quite amazing, really.
Yeah.
Some of these formulas have been used for so long. It shows how smart they had to be able to sit down without the technology we have and form these equations and realize what they did. It's fascinating, really.
It is mind-boggling what the thought. I as a young chemist, I look back and looking at the periodic table of the elements, and I'm thinking, the Russian Mendeleev, who came up with this, only had about 30 or 40 elements on this table to work with, and yet was able to pinpoint what the other elements would look like, how they would behave, and pretty much what mass they would have. This guy was genius would be an understatement, a serious understatement, and able to put that together. And to this day, whatever experiment you do, whatever industrial application you have, Mendeleev's work is perfect. I mean, that's science.
It's great. And we have, though, the opposite happening around us. We have people that are acting so dumb, they act like they can't get these simple things we've just put on the screen. And I think there's a lot of deceit going on, personally.
Yeah. We'll come to that. One of the things, actually, they say some very, very offensive things. They say, Newton was dumb, Einstein was dumb. Wow. It's those sort of things you think, how did
bold.
how did you get to be an adult?
Yeah.
You know?
Oh, yeah.
How did you even learn to tie your own shoelaces? You know, you seriously got to think about that and say, well, you cannot be serious, and you can't be expecting me to take you seriously when you say stuff like that. Okay, yeah. You may, I don't know, you may disagree with what Einstein says, or you may disagree with what Newton says, but to call them dumb, that is really, really stuffed up.
It's really narcissistic, I think. That they have the, and I noticed there's something came up. Was it? I think that before the conversation you had with Riley, that maybe you had told him he was narcissistic or something, and he got really hung up on it.
Well, you know, this is another issue where they of being disingenuous and dishonest, actually, and that is point out what I said without pointing out what he said first.
Yeah. Oh, okay. Yeah. The minute the word came up, my first thing was, well, you're acting narcissistic right now, Riley. So it's like, yeah, but right. Go ahead. I'm sorry.
And it doesn't even point out what he said before that. So because if I used that word narcissist, I'm referring to something that he said previously.
Yeah.
So in other words, I'm responding to his comment when I say that, and I would use that word appropriately for something that he'd said.
Well, what do you mind telling us, or do you not want to? It's okay if you don't.
I can't recall off the top of my head, but let's say, for instance, I would, if I called him a moron, this is as a result of saying that Einstein was an idiot.
Yeah. Oh, for sure. And it is a dumb statement. It does sound like it does make him sound like a moron. He needs to hear that and realize it, and then maybe he'll get why he sounds so stupid saying it. You know, it might help him a little.
Yeah, exactly. So I think calling him a moron after saying Einstein was an idiot is kind of being kind.
Yeah. Oh, for sure. I agree.
Yeah. So
they studied the man's brain. They kept his brain to study it. That's how much of an impact that he made. They're like, something has to be different about Einstein, and he's calling him an idiot. It's crazy.
Yeah, exactly. You know, one of my favorite pictures of all is the Solvay Convention, where we've got about 50 of the greatest minds, other than unfortunately Newton, Lavoisier, and a few others who obviously weren't there, but 50 of the greatest minds from 1900 onwards sitting all together. So Curie, Planck, Bohr, Einstein. It's just amazing. Like, someone like me would just say, if only there was a time machine.
Mm-hmm.
You know, that's where I would go to shake some of those hands. Okay, let's move on. So look at this. The North Pole to the equator, 6,257 miles. Okay, so these are, figures that I would have drawn, so I haven't actually measured these. So personally, and I don't need to, other people do that. And I have no reason to disbelieve what they say. So therefore, the distance around the equator on the AE map is 39,000. So we have people going around saying, what's the distance around the equator? And they go, 24,000 miles or thereabouts. Well, sorry, if you think your model is right, then it's 39,000 miles. Now, here is the simple equation, which some of them don't even know how to do. Some of them don't even know that a triangle with equal sides has 60 degrees, at each angle. About Mr. Wright.
I saw that video.
Okay, so hang on a second. You don't know what an equilateral triangle is, and you're going to tell me that Einstein is an idiot, and you think I'm not going to call you a moron.
Exactly.
Well, you shake your head so much it's going to come off.
Yeah.
All right. So now a person who looks at that and says, okay, well, now I'm going to have a look at the sun. So for the sun to travel this distance, and it's going to go at 15 degrees per hour, you can't argue with that. You can go up and have a look at it. Okay. Mm-hmm. And it goes around once in 24 hours. it's going to need to travel 1,638 miles per hour. How are you not going to see that moving?
Yeah.
You're going to physically look at it going away from you. So who can stand there and look at the sun and say, look, I can see that move? I don't think so. But in this case, you most definitely would. It gets worse. Let's have a look at this. This is another depiction there and looked at. So I actually did some measurement, a little bit of arithmetic here for their benefit. North Pole to the equator, circumference 2 pi r, so we've got 39,000 as I discussed. North Pole to Brisbane. So Brisbane is our city on the east coast, about halfway through, and you can see the green line there, which would, it's quite not far enough to be the Tropic of Capricorn, but definitely would go through what we call Brisbane, that city. And that would be, so the North Pole to Brisbane, 44,748 miles. Now, the thing about this particular map is, it's actually a real map. It's not a pretend thing. They didn't invent this. This is actually a projection, squashed out from the pole outwards.
Oh,
so,
gotcha, yeah.
And it's a genuine map, and the distances from the pole to various places are accurate. It's the lateral distances which are totally wrong, but the distances, the longitudinal distances are correct. So, if you look at this, therefore the circumference where Brisbane is 44,741 miles. Okay, so how fast is the sun going there? 1,864 miles per hour. Wow. I wonder if Brisbane is 100 kilometers across, I wonder how long the sun would take to cross Brisbane. You'd wake up in the morning, oh, there comes the sun. Ooh, okay, there goes the sun. That's it.
Yep.
Sun's gone. That's how fast it would go. Sun over Melbourne, this is where I am, 3,336 miles per hour.
Oh, wow.
In other words,
that'd be like an hour-long day or what?
I get to no, that would be generous. 20 seconds.
Oh my goodness.
Okay, 20 seconds.
Oh,
over.
I see. Yeah. Okay. Gotcha.
20 seconds over my city. Okay, I would be hard pressed to get the car to keep up with it. So, why are they not asking themselves this question? Why are they sit down together and sit down with someone like me or people who you don't have to have you don't have to be a scientist. You just have to have someone that's in common sense. Sit down together and say, let's work through some of these things. And then you look at this one and you say, wow, I have to throw this one out because it just doesn't work.
Mm-hmm.
I've just explained that one. That's all right. So in other words, us in Australia, we'd actually see the sun racing across over our heads. And like I said, 20 seconds. That's about it. Okay. So to get my little coupe to keep up with it, that would be impossible.
Yeah.
It's not fast. Okay, conclusion. If you're confident that a model that explains all of the above adequately and simultaneously, so it's coherent, we can move on to other things. So let's deal with those few things. I gave you, 8 or 9 things to look at. There are thousands of things to look at. This is just 8 or 9. If you get past those 8 or 9, it's worth looking at the others. Then we can start looking at things like gravity, planetary motion, etc. Because what is the point of wasting any more time on that particular model, looking at gravity or planetary motion, if we can't even deal with the basics like how does night and day happen?
Exactly.
That simple question can't be answered. Okay, that's with that one. All
Great
right.
presentation. I love it. It puts so much out on the table, and these guys would be busy for months if they would just sit down and, try to go through this, and they'd have a reason to have their discussions. It would give a purpose.
Absolutely. Look, the thing about it is that it's not been all bad because probably never have so many people been thinking about science, all at once. And so this has kind of had some, there is a silver lining there, where people are actually talking about it, but hopefully they care enough about what they think to look into it further, which then would lead to them saying, I'd like to learn a little bit about physics, or I'd like to learn a bit more about the cosmology, And then the people like Neil deGrasse Tyson and that who are really the public face of science and who are the educators, if you like, the public educators, what they say wouldn't go to waste. So let's just have a look at this is the perspective of somebody's, from an academic perspective. I'll just start this one off for you. Okay.
Yeah. So I'm excited to see this because
Okay.
I'm astonished at how you and I both think a lot of the. I agree with you on so much of just the little bit I've seen. So I'm happy to get into this.
Yeah, okay. So the question is, who are these people? All right, and there's some faces that I think everybody who's been looking around this will be familiar with, and I think I've pretty much got most of the. Look, there's quite a few missing there. I think Jaren isn't there, but there's a few missing. But these are the ones from the UK anyway. I suspect that's probably why they're all together like this. They all come from the UK. So there are a few American ones like Effie Core and Geran and there's Morgile, I think.
Morgile and
yeah, there's a few. I don't know all the names, to be honest. I've sort of come across some of them. Eventually, it gets a bit boring because they all say the same things. All of them say the same nonsense, and all of them make the same silly claims.
Mm-hmm.
Yeah, right. So this is let's have a look at this from Maslow's hierarchy. So why do they do this? It's a good question. So if we look at it from the perspective of Maslow's perspective, we've got those 3 stars you can see there point to probably those stars might represent size as well. So love and belonging. So belonging as in wanting to be in a group, feeling left out. Because if you were a layperson and it's our fault, science does leave out the lay people. I think science is treated with a degree of elitism, and it shouldn't be. So it's like the them and us sort of thing, and it's wrong. It shouldn't be that. It should belong to everybody. And scientists have an obligation to share what they know in a way that's accessible to the general public, and they don't. So they include all the jargon, which makes it not accessible to ordinary people. Ordinary people would look at it and then just simply walk past and say whatever, and not actually take some time to try and understand what it is. Then you've got esteem. So the groups of people who somehow have felt left behind have suddenly found something that they have in common that does give them some esteem. So in other words, they're learning things, but they have to learn things that other people don't know. So in other words, they're saying, so it's as though they've discovered new things. And this gives them a strong a sense of self-esteem. And then if you move on further on, so they'll develop from just wanting to belong, gain more confidence to get to where they have this self-esteem, and then finally have the courage to go on the street and proselytize their thoughts about this, I would say that they've reached this self-actualization. That's what they're aiming for. There's some key people in that who are pretty much treated like gurus or gods or prophets by most of their community, and I would say that they would want to hang on to that position that they've got to, this self-actualization position, which is hard for most people to get to. And so they've got there. They have the recognition. For instance, they would have the recognition that someone like Einstein would in the real world. They've got people who are actually devoted to them. I don't mean just I believe what you say. I'm talking about devotion. Okay, so that is ultimate self-actualization. They're not going to give that up easily, and certainly when people like me who actually don't care about their particular journey to self-actualization come up with answers that pretty much send them back to the bottom, the psychological area, beyond safety. In other words, we've not just torn apart the first three triangles, we've actually torn apart all of them, so that they now in a place where they're worried about their safety and their psychological safety. Who the hell are we? Why are we doing this to them? Why don't we just let them have their self-actualization? Why do we need people like me coming down and saying sorry, but you're all wrong? And we do, and certainly from my point of view, because this leads to all sorts of other conspiracy theories, some of which are detrimental, in fact, are an existential risk to the rest of us.
Definitely.
The anti-vaxxers, and the climate change denialists. Mm-hmm. So those are anti-science people. These are existential risks, and they these people over there are in danger of getting more and more people to agree with them, and that would be fine, except they vote.
Yeah.
They're allowed to vote.
What you just said, too, is one of the biggest channels, that if it's not the biggest Flat Earth channel, is named after his own name, which is ironic after what you just showed us, I think. Yeah,
exactly. Yeah, and that's the ultimate in self-actualization.
Exactly.
Yeah. So that's not, someone like that is not going to relinquish that title easily.
Oh,
it's taken a long way to get there. It is how they function. It is actually part of their psyche. That is a huge thing to take away from somebody. So you can understand why they would get angry. Sleeping Warrior getting angry with me, it's totally understandable. Here I am, not understanding his particular needs in terms of Maslow. I'm not understanding his needs, or even if I am understanding, I'm seemingly not caring enough to want to protect it for him. So he has every right to be angry. He should be angry. He
was.
But he was. But you know something. It is not about. I'm sorry, but science is, doesn't actually have feelings for you. Okay,
it shouldn't. It would definitely cause a lot of problems if it did, I'm telling you.
Yeah. Actually, it did once upon a time, and thankfully, it's managed to shake that off.
Yeah.
So that we have ways and means of finding facts. Okay, and we need to. Otherwise, we wouldn't have industry if we didn't do it that way.
Definitely.
All right, let's move on to this. So just in some pub research. So I take this with a grain of salt, but I think it. Just looking over it, I think it's close to it. So I would say that most men over 40 who claim to be flat earthers are genuine. So It's a pretty broad statement, but
Dell,
just looking.
Dell fits, and he means that.
Yeah,
I do get that feeling about Dell.
Yeah. Well, have a look around, and you'll see that that you'll see the names, the main names, and those ones that follow them. And if you follow the chat, you'll see the ones who are that, and you'll find that they mostly the ones who actually really believe it, who genuinely believe it, are sort of beyond 40. And this would be consistent with the idea that technology is moving at breakneck speed, and those people over 40, like for instance, look at my case. I was actually around when the calculator was invented. I actually started my first year in college without a calculator. I actually had a slide rule. So it was only in the second year that I got a HP 21, I think it was, that cost me about 3 weeks worth of wages to buy. Yeah. And then I wasn't able to use it in the exam anyway. I had to use the slide rule in the exam. Go figure. Never mind. I did have but it led to bigger and better things because later on I invested in a programmable calculator, and I pulled it apart, and I managed to connect the output of the input and the output of the calculator, one to a printer and the other end to an atomic absorption machine that we had going. And the reason I did that was because this atomic absorption machine meant that you did your sample, you worked out what the absorption was for a particular sample, and then you had to write it down. Huh. So I kept having to do a sample, write it down, and this was getting quite tedious and open to mistakes. So I thought, well, why can't I just add the calculator in this train, and then the calculator can actually produce the curve for me, because you write these things down, and then you had to do a curve, and then you had to determine where your blank sample was according to this curve. Well, I thought, if I could get the calculator to actually do the curve, to produce the figures, that would make my life a lot easier. So the calculator became handy for that from that point of view. Well, now of course it does it. Now you do it. The curves are all done all automatically. So, but that was in those days, when we were just beginning. And it just goes to show how science and technology progresses together.
Definitely.
So now the other thing about it is that I had to look at the women involved, and I found that most women of any age, so there wasn't a particular age, so young women, older women, if they believed in the flat Earth, they were genuine. So there were very few shonks amongst them. Maybe they weren't prepared to go further and look at the hard questions, which they weren't. But they weren't there to take money off anybody under false pretenses. And then looking at the next group, which is those who are around 40 or younger, so the younger people. The younger people tend to accept technology and accept change because it happens so quickly. Young people, when I was 16-year-old before I saw my first television set, because television wasn't allowed where I was, actually. 1956, I think, was the first broadcast of television over here in Australia. I wasn't here then, but I was born before then. So there are many of those older people who were born long before television. Technology is really scary, but yet these young people, they were born with calculators. They were born with, many of them born with mobile phones, with cell phones. Born with television, born with all of this technology. They're used to technology. For them, thinking about a spacecraft or a satellite is no big deal at all. Why wouldn't it?
Definitely.
Why wouldn't you have satellites? So the younger people who are used to technology, who are born with technology, are not surprised by it anymore. Whereas the older people, we're thinking, oh my goodness, the first time I saw a television set, the commercials, I was fixated on the commercials. Forget watching the movie. I just wanted to watch the commercials.
They're like mini TV shows, so
It was fascinating, and I'm thinking, I had to learn how this happened. So my interest in physics and science, because I'm thinking, how can that be, And so for someone my age who never got the opportunity later on to go and study how does this happen, it must still be daunting. So you can see why someone in that position who doesn't understand the technology, who sees it flying past them all the time, thinking, I've got no hope of keeping up with this, and I don't understand it. It's daunting. It's scary. Whereas to young people who are born with it, it's nothing. There's no reason for them not to believe that satellites are there. So this comes to my point. Those people are not genuine. They're in it to make money. They're in it because the older people pay them. They pay them to say stuff that will appease them. They pay them to say stuff that will raise them on Maslow's hierarchy, that will make them feel good, that will make them feel connected, that will give them esteem. They pay for that. That's what they're paying for. They're not paying because Geran's a good-looking guy. They're paying because he's saying stuff.
I agree completely.
Helps them. That helps their psyche. Okay? And they don't want to ask the question because that will break that down. And then this one avenue that they have for raising themselves up in Maslow's hierarchy will be broken. And they certainly wouldn't be able to tolerate that. In the last point here, the majority of Flat Earth channel owners fall into group 3. So as I said, they're there to make money. They've realized that this is an industry, and that there's people out there who'll pay them to say the things that they want to hear. That's always been the case, isn't it? What do you call religion?
Yeah.
People saying stuff that you want to hear.
Definitely.
So, and which religion do you belong to? The one who says stuff that more appeals to your set of values. What do you do when you go there? You pay them. Nothing is new. It's the same story. It's been going on for thousands of years. Nothing's changing. The only thing that's changing is the narrative. The reason for it is still the same. Okay. So, like I said, it's becoming an industry, and as far as I can see, it's getting to be as strong as the anti-vaxxers, the homeopathy, the numerology, talking to dead people, all the other money-making woo that's happening, that's going around. It's no different, and it's getting pretty strong. The thing about it is that the anti-vaxxers, if you're silly enough to give your money to the homeopathy, and somebody tells you, I'm going to give you this this vial of salt, and then I'm going to call it something like what's the name for Na? So I can't even remember. I should know this. Yeah. So
I don't know.
So natrium chloride, the chloride of natrium. That's what they'd call it. They call it the chloride of natrium.
Oh, okay? I got what you're saying. I get what you're saying now. Okay.
So now dressed up sodium into natrium because it sounds better. Okay, the chloride of natrium, and then they're going to say, well, I'm going to dilute this by 30 to the 100. Okay, this is how small I'm going to make it. Well, I'm thinking, let me think about how small 30 to the 100 would be. Okay, It would be like if you had a teaspoon of salt and you went out into the Pacific Ocean
and dumped it.
And you dumped your teaspoon of salt there.
Wow.
And you claimed for all the world that you made the sea saltier. That would be overreaching compared to saying that you made that, compared to diluting something at 30 to the 100, even 100 to the 30, even if you put it the other way around. It's so ridiculously small, there would not be a single molecule, which of course is ridiculous because there'd be a whole bunch of other molecules, because you couldn't possibly get your deionized water or distilled water to be so pure H2O that it had no other molecules of anything else in it. So now you're going to go and pay $36 for this vial of water, basically, which supposedly has one molecule or less of sodium chloride, which is nonsense, because you couldn't possibly get anything with it.
And that reminds me, I've been fighting against this new thing that they call Miracle Mineral Solution, and it's basically bleach that they give to you, and they tell you it'll cure you. And we were debunking that for at least a couple months, about 8 months ago, I think, 9 months ago, and trying to get a good change going there, because they were selling it in a high enough concentration to actually harm children, and it was pretty bad. And they were getting rich off it, though.
Precisely, and that's the kind of things that I see all the time. For instance, people selling, simple things like carbon filters. And yes, they do filter, but you have to change the filter, or you've got to clean it all the time. Otherwise, it doesn't. Not only will it not serve the purpose, but now it becomes a breeding ground for other pathogens. So,
what do you think flat earthers would? I mean, they'd probably be angry to be compared against people that do this, but really, it's an accurate description, you know.
Yeah. Why is it different? You know, the thing about it is that so what worries me are the two main things. So if you want to give your money to somebody who claims that they can cure you with one thing or another, is that's up to you. But I take objection to the people who are convinced, let's say if they have cancer, not to take the going science, to ignore their oncologists, and then to head down the path of woo. The people who are anti-vaxxers, you know, when I was a child, you know, 5 of my classmates had polio. None of them survived to adulthood. Mothers were scared to let their kids go out and play because polio was rife. And then Mr. Salk came around. And yes, there were mistakes, but millions and millions and millions of lives were saved. It wasn't that long ago, when I was in India, a couple of years ago, that the very last known case of polio was finally gone. It was finally detected. Okay, now this is because of the great work that was done by people like your own countryman, Bill Gates, and his So people like that who amassed lots and lots of money, you know, helping, getting rid of that scourge of polio. I recall, as a kid, watching children who had whooping cough, pertussis. I mean, this is a mother watching her child, go, and not being able to do anything about it, practically just coughing itself to death, not being able to do anything about it, and yet now practically non-existent, except of course among handfuls of communities that think that they're immune and that they don't need vaccinations.
Yeah.
So
a lot of diseases are making a comeback now. Was it mumps or measles?
Yeah, look at measles. I mean, people think, oh, look, when I was a kid, we used to purposely go out and play with our neighbors so that we'd get measles. Well, if you might be one of the lucky ones who can recall a history like that, but there'll be many who can't, and there'll be many whose brains were destroyed as a result of it. Yeah. Who can't speak that, who can't testify that your claim is nonsense. Okay. Anyway, let's move on. So the protagonists, the professional Flat Earth channel promoters, these are the groups. There's the professional Flat Earth debunkers. So they're also part of this industry.
True.
So they're making money as well, the people who are debunking and the people who are promoters. So in a way, then we have the amateur flat earthers, the genuine ones, and then the debunkers. People like me who've got the day off and want to spend their time talking on YouTube. And then all of these people have a love-hate relationship because they need each other. So in other words, the professional Flat Earth promoters need the debunkers, and the debunkers need the Flat Earthers, okay? Because they keep this rage going, they keep this conversation, this discourse going. If any one of those fell off, then the Flat Earth thing would die, or the debunkers would. But either way, this is now an industry, and it's making money go round. But, it has the silver lining, as I said. It's also making science, to those people who actually care about what they think, science is becoming a bit more accessible to them. Okay, so let's ask some questions ourselves. Will the Flat Earth survive another 5 years? Good question. And I say no. Not in its current form. Flat Earth will devolve into a fringe cult-like status as the young pose and trolls get bored. So those people, the young ones who I described, who understand technology, they will, they'll eventually get bored with this. They'll want to move on to something else, and that'll come in a few minutes. What they will do, and eventually it will shrink to the point where the people who are still in it are really in a cult-like status. That's my view on that. Yeah. Okay. Young, genuine flat earthers are too lazy to do some actual research, and that does not involve watching. They're too lazy to do research that does not involve watching flat Earth videos created by pretend flat earthers, which is the ironic thing, isn't it?
It is, yeah.
Yeah, that's the irony about it. The people who are actually making the flat Earth videos, those don't actually believe themselves that the Earth is flat. For instance, Globebusters and FE Core and these people who set up these conventions.
Jeranism,
Yeah. Look, I feel sorry for the genuine ones, and I've said this to you before. The genuine ones, who go out there who are proselytizing, they actually believe this, and they believe it because of the people like Globebusters and FE Core and Eric Dubay. It's because of them that they believe it. So they normally wouldn't fall for something like that. But they need to be on this Maslow's hierarchy. They need to be in this place of acceptance. They need to get to esteem. and this seems a credible way to do it. Okay, but the people who are actually promoted are not actually part of them. They don't understand that. They think that Jubei actually believes what he says. They think Globebusters actually believes what they say. They don't. No. They just need to come up with more content every single week so that they can get some more money. That's how they do it. That's why they do it. Okay, flat earthers are not interested in creating a flat earth model that scientific community will be. Of course they're not interested, because the first time they try it, it will be patently obvious that it's too hard to do and that they are wrong. So they are correct in their assumption. Okay, they correct. If this was what I did, if I was a grifter, I would not be interested in creating a model that could be debunked. That I would not be interested in answering tough questions, because it would take away my livelihood.
I would argue semantics instead of actually understanding an argument.
You would have to, because every time somebody like me puts up an argument that says, please explain how the sun gets around without a magic lampshade, the way I'd argue with that was I'd take the politician's method, and I would answer your question with something that you didn't ask. I would say, for instance, you know something? Your question is no good because it's not science, because you didn't wiggle this and you didn't wiggle that.
Yep.
So therefore your science is no good. Or you are relying on some equation that was done by Newton, and Newton is not the current science. So therefore it doesn't count. Never mind the fact that it works. Never mind the fact that if you're in the Navy, you have to shoot a ballistic missile at something. You're going to be relying on two vectors. One of the vectors is horizontal, and the other one is vertical. Well, guess what? The vertical vector is going to rely on gravity. Okay? Do they think those people in the ships who shoot a missile worth $5 million are just going to guess where to shoot it? No, they're not.
They argue about missiles a lot. They do. I've heard it myself.
Well, they're going to use Newton's equation.
Yeah.
Okay? And they're going to hit the target, because Newton's equation is going to tell them exactly how high the missile is going to go.
I'm really glad you said that. I'm sorry to interrupt, but
okay.
I'm glad you said that, because the Sleeping Warrior always says what you just said. The Einstein, takes over for Newton, or whatever his sentence is there, but. And it's so ridiculous. He's so wrong. And those little arguments are what really expose him for what he's doing. But I won't interrupt. We'll talk about it later.
No, that's okay. Look, I'll tell you what I'll do if you like. I was going to post this on my channel, but I'm happy to do it on here with you if you like. And that is, if you want to devote an evening to, well, not the whole evening, but just a little while, just to discussing how it is that Newton's model and Einstein's model fit together. I put up a very good explanation that could be directed at lay people. In other words, I'm not going to put in all the jargon and all the mathematics. I'm going to describe it in a way. Yeah. So I'd like to do that and just show people that they're wrong, and that is it can't make sense that we use Newton's model for hundreds of years. It's astonishingly precise, astonishing accuracy for stuff we spend a lot of money on, like, for instance, the $600 million that it takes to put a decent satellite in. If you're going to spend all that money, and then you're going to rely on this particular formula, you better believe it that formula works. Because $600 million is a lot of money in anybody's language.
Definitely.
So to suggest that every single month, so let's say from India, every month satellites are launched. This doesn't count from everywhere else. Just today, there's one going up from Japan. There's everybody, the 72 agencies around, at least 8 or 9 of them would be doing this on a very regular basis. It's an industry. All of those satellites up there have to be replaced. They don't last indefinitely, and technology improves. There's better ways to do it. There's stronger signals. There's the GPS satellites need to be replaced. The military wants to be able to see better. There's all sorts of reasons why those satellites, the ones that are up there, will be sent into the graveyard orbit and stay there, well, practically forever, and then be replaced by new ones that do better things, because science gets better and better. Okay, so as long as their main message is that Earth is flat, flat earthers are going to be ridiculed because they need to change that model. It doesn't work. So this is the killer, though, and it's going to happen within the next 5 years. Space tourism. This is a real thing. I know they keep laughing about it, and they keep saying, well, they've been saying space tourism for the last 20 years and it hasn't happened. Well, sorry, but it is happening. It's happening right now. Mm-hmm. People actually pay to go to the ISS, but that's a multi-million-dollar cost. You sooner in the next 5 years, you'll see that craft will go to the edge of space. At the edge of space, you'll definitely 100% be able to see what shape the Earth is, and these people will come back with their awesome pictures. It'll be undeniable. If you've got half a brain, you will have to say, yeah, okay, you got me. Conclusion. Current diehard flat earthers will move back to mainstream victim-oriented conspiracy theories like anti-vax, chemtrails, Illuminati. That's where they're going to go. So people don't just stop being conspiracy theorists. They just move from one thing to another. So they're going to be moving back to the anti-vax, but I'm coming up with a bit of a doozy for you about where they are going to go. But they'll be moving back to these things, and then you'll hear a lot more about chemtrails. You'll hear a lot more about Illuminati. You'll hear a lot more about one world order and all those sort of things. They'll be much more prominent in YouTube than Flat Earth will be. So Flat Earth will devolve into a small fringe cult-like community. So they'll still be around. There'll still be there's people who believe just about anything, and they will still be there. And it's their fault because they are not asking the hard questions and getting themselves noticed, or certainly not taken seriously. Flat Earth debunkers will occasionally knock off the Flat Earth heads that pop up. Okay, so that'll continue. So every now and then there'll be a Flat Earth video, and then someone will say, well, wasn't that silly, and then do a show to ridicule them. So that's going to continue. But again, that'll get smaller and smaller. I doubt whether there'll be enough money in it for it to be an industry. I think the Flat Earth debunkers will probably have to start working on debunking anti-vax, chemtrails, and Illuminati. I doubt there'll be enough Flat Earth stuff in it for them to make any money. What happens to globe busters and people like that? I think they'll either have to go out and get a proper job, or they'll just have to probably jump on some other conspiracy. And this is it. What next? Aliens. Okay, aliens is next. So it's already started. We've got all these bunch of people going to Area 51. They're not going there because they love to travel. They're going there because they actually believe this. And then, so this is it. There'll be aliens. More and more people will see them. People will photograph them. There will be the debunking industry. There'll be the alien industry, and we'll be doing this again in 5 years' time. That's it.
Excellent. Excellent, sir. Yeah, I'm love the presentation, and I can honestly put so many of the people that I've seen out on YouTube into different classifications of one of your first slides there. The for over 40, under 40, it lines up. It's definitely on point.
Yeah. You look at any of these, they fit. So you could just about look at these and pick them out, and pick out the ones who are faking it, and pick out the ones who are genuine.
Yeah, I guarantee you, Del. I just was watching him yesterday, and I could tell that he's really upset by a lot of the things that are going on, and because he does truly believe what he's doing.
He absolutely does, and for people like him, so I have a lot of respect for him. I respect him because he genuinely believes in what he says. I think he's the type of person I'd like to sit down and have a beer with and say, listen, this is what I know, and this is why I think what it is. And then and Del is a genuine person. I think he would eventually agree and say, look, I've either got to start from scratch or drop this altogether. And in a way, you can tell that he's genuine, because he doesn't come out and say, I've got a model.
Yeah.
Okay? Because he's smart enough to know that this dome idea doesn't work. He's smart enough to know that this flat Earth thing model that they put out there, the AE model, doesn't work. All right. So I'm pretty sure he's non-committal, because he understands the problems that are there. Okay. One of the things that, for instance, there's two things that I haven't really covered, and that is that come from Del, really, and that is this continuous thing about how come a vacuum can exist next to a pressure system. So you hear this a lot.
Oh yeah.
Okay, and so there's really only two things that they can hang their hat on, and that is this business about the water, and I've explained that already, how water are molecules, and therefore it's going to be a sphere, whether you like it or not. But this other one about the pressure gradient. So I've got a lecture on my channel, if you don't mind me promoting that.
No, please.
I've got some lectures on my channel. So what I've been doing is I've been putting a few of the key lectures that I have with respect to, for instance, there's one that discusses what is mass, because very little is understood about what is mass. So we describe mass. One of the things that Sleeping Warrior goes around saying, well, gravity is not a force. And he says, Einstein said gravity is not a force. The irony is he's asserting Einstein's view and then saying, on the other hand, but then I don't believe in Einstein.
Yeah.
So Einstein's an idiot. This is his words. But Einstein says gravity is not a force. So therefore, I'm going to assert that gravity is not a force. Well, there's some truth in that. But gravity ends up being a force because of the mass. So in my lecture, I go through, well, if we're going to look at gravity, it's important for us to look at what mass is, and where that comes from, and how can we distinguish one mass from another. So I would, if you've got some time and you're genuinely interested, I'm telling
Definitely.
your listeners, have a look at one or two of these lectures, and if you have any questions, please in the comments area, raise your questions. I'm happy to answer them, and if I can't, I'll find someone who can, and if I can't find someone who can, I'll say I don't know, and maybe you might raise an issue that's worth looking at. Happy to work with anybody who has a question that needs answering. Okay, the thing is, I'm an educator. So as an educator, I want to be able to spread the word around. I want to be able to help people understand science. If people understand science more, they'll vote for those people who are interested in science. And if they vote for those people who are interested in science, then they probably will save the planet. The way it's going at the moment in your country with, I don't know, not all that hopeful.
I hate politics all around. I don't mind talking them sometimes, but yeah, it's a mess right now. That's my perspective summed up.
Yeah, it is, but it's like anything though. It's short-lived. The mess is short-lived. The thing about it is that the entire community is resilient, and they will eventually make the right decisions that are in the interests of their community. So I'm pretty confident that in the end it'll work out. Things might change. People who have beachfront property might have to move. But in the end, societies bend and shape, and eventually we'll work it out.
If we could get Dell to actually sit down sometime and come talk, would you be interested in coming to talk to him here?
Oh, absolutely. I'd be surprised. I'd surprised if he doesn't shout at you though.
Oh, he already has. He doesn't like me much, but I might be able to get him to come if I.
Yeah, no problems. Him. There's a few other people who proselytize who are happy to proselytize and then ignore some facts, even when you tell them to, they then still continue. There's one in the UK. I think his name's Jason. Anyway, he goes around saying. Talking about the shape of the Earth, and says we've got this formula, and he calls it Pythagoras formula. And I've told him at least a dozen times, please stop saying Pythagoras and say Pythagoras.
Yeah.
No, he's decided. He's decided the guy's name was Pythagoras, and he's going to keep saying Pythagoras.
I wonder if it's a strange tick the guy has or something, or what.
It is. I mean, if someone just points that out to you, why can't you just look it up and say, oh, wow, that guy's right. I'm going to stop saying Pythagoras.
Yeah. I think. I've met a lot of people that do that, though.
Yeah.
They have an issue with it. Okay, we got a bunch of questions, actually, that our mods have been...
love it. Love it. Go for it.
And let's see. And mods, if you can, since you've already been doing it, if you want to drop any more questions into the same Discord room, it'll help. But let's see here. Oh, and I have a picture I want to show you before you leave. It's a picture of a conversation Anthony Riley and Nathan Oakley had once. But I'll show you that before we go.
Sure.
Okay. So here we go. Oh, great question. All right. So if you can... When you copy them, if you write their name.
Okay, what do I need to do to see your screen?
Oh, I'm about to read them out. I'll read it out to you.
Okay, sure.
So the first question is, have you read Anthony Riley's thesis paper that he released recently, and what do you think about it?
Okay.
If you have.
I have to conclude. I'm sorry. I've seen bits and pieces of it, which look like a copy and paste from various sources. I doubt whether I would, when papers are presented for academic review, they would go through a program that involves checking for plagiarism. And also, so I don't know. I can't say it wouldn't pass that, but I think if you go beyond. If you go beyond using I think it's about 25%. Is that right? Okay. Yeah,
I think so.
Nodding at my wife over there. I think if your whole paper has more than 25% counted as plagiarism, and if you did do that and present a paper like that and put your name on it, 100% you would be disqualified, if not kicked out.
Yeah, so I'll ask this question off of what I read. So he presents the thought process that many alternative theories are presented in schools and in education, and he thinks that flat Earth being restricted from being an alternative thought process, he thinks it's wrong, and he thinks that if he submits the right kind of paper or the right kind of theory or something, that he could get schools to put flat Earth into their curriculum. That was the basis that I got from it.
Oh, okay, all right. Well, that's an interesting way of looking at it, but it's a total misunderstanding about how school works and how education works. I'm just wondering how long ago he was in actual school, because if you were there and you said to your teacher, I think the Earth is flat, and I've actually used that very thing in a class to cause students to think about it, to think about how they would, what can they see in physics that would convince them that the Earth was not flat or that is flat. So I was saying, you bunch of people over there, you pretend like the Earth is flat, that's your job. And you bunch of people over there, you reckon the Earth is spherical. All right, I want to see the physics. So you flat Earth people, you show me the physics, okay? Well, needless to say, I didn't get much out of the flat Earth people. It's not their fault. They didn't have much to go. All right. But the point is that I got them all thinking about this. All right, and that's how schools work. It isn't I tell you something and then and I don't give you a good reason for why I told you. That doesn't happen. If I say the Earth is a sphere, I'll give you some very good reasons why I think it is and why I think it can't be something else. And if you came up with an idea, we'd look at your idea and then we'd see if it had any merit. Schools are not religious organizations. We don't try to indoctrinate people. We try to get them to think. So schools is about teaching you to think.
Yeah, I always disagreed with them when they talk about Arwen loves to sit and say that it's an indoctrination in our school system. And I remember in school asking questions, talking too much, and entire classes being all of us sitting around raising our hands and bringing up new points. And, you know, it wasn't the way for me that they described. And I don't think it was that way for them either, honestly.
And it's not the same for most people who get involved. So yes, there'll be some people who sit at the back of the class and cause a ruckus and cause trouble and do things. And then there's the other people who sit near the front and like to put their hands up and get involved with the teacher and get involved in the lesson. So the ones down the back, maybe it did pass them by. The ones that weren't interested, but the ones that are up the front there who put their hands up and who ask some questions, funny questions, odd questions, it didn't matter. You asked a question and then, and maybe everybody got a laugh out of it. So what? We all learned some science along the way.
Yeah. Well, here's a question from a flat earther, I believe, and this might be because of the Morgile. The Morgile put out a video. Oh, go ahead. Sorry.
No, go ahead.
Sorry. The Morgile put out a video where he yesterday or the day before, it has to do with the moon being in the sky during the day and blah, blah, blah. Now, for anyone watching, Professor Dave Explains, Simon Dan put out a complete debunk if you need this answered technically, but I'll ask Professor Phil, how can we have a full moon during the day? Wouldn't the sun be behind the moon?
No,
I already know the answer, but
well, I don't know. It's a good question. I haven't thought about it. Full moon during the day? I don't think so.
I don't either, and that was the determination of Simon Dan, and he requested a picture proof from Morgile that would happen. So
no, yeah, he's dreaming.
Yeah,
show us a picture of a full moon during the day.
What's funny is he put pictures on the screen, but none of them were full moons. You could just see that they weren't. So
you'll be able to see a slither or whatever, but full moon. Look, I think, put it this way: if you wanted to have a pretty good idea, the next time you look at the sun, when the sun and the moon are out at the same time, hold a ball in your hand up in the sky and look at the shadow on the moon and compare it to what you see on your ball. It'll surprise you, but they will look exactly the same. Okay, so hold the ball up, have a look at how the light shines on that little ball that you're holding up in the sky. The sun's out, the moon's also in the sky. Have a look at the moon and have a look at how it looks on the moon and have a look at how it looks on your ball, and lo and behold, they'll be the same. Now, if you care about what you think, ask yourself the question, how come that is?
That's a good point. It's a great point. We got a really good question. I'm going to ask it first.
Sure.
What was your inspiration for doing what you do? Just a more general question there, but
In science?
and yeah, in your job and your work.
Okay, well, as a little kid, I used to go around in the kitchen and grab things and mix them together. And eventually, we used to have crackers in those days, fireworks. Mm-hmm. So I'd pull them apart, because I was interested in why they exploded and stuff like that. So I mixed all sorts of stuff together. My mother, I used to scare my mother, because she'd get all sorts of smells in the house. Thankfully, I never got to mix chlorine with vinegar because that produces, bleach, because that produces chlorine gas, and that could have done the whole family some damage. But I never got to do that, luckily. But I did create all sorts of other wonderful smells around the house. And I was just fascinated about how these things went together. So even in primary school, I could do the work that probably O level, so about 10th, 11th grade chemistry. So I knew my chemistry pretty well, even as a primary school kid. And so I was just completely in awe of how that happened. People like Curie and Lavoisier and people like that, Mendeleev, they were my heroes.
Excellent. Here's I don't know if it's a trolley question or not. We kind of hit it, but if you want to give a quick thing here. My question: does he believe that flat Earth is a scientific problem that needs to be disproved, or is it more of a cultural education issue? I know we've pretty much addressed that, but if you want to add anything, you're more than welcome.
Obviously, it's a cultural problem. I wouldn't call it a problem. I would say that it would be like, imagine you're in the classroom and everybody's discussing something, and then there's some people at the back who suddenly wake up and say, gee whiz, I'd love to join this lesson. You know what? Can I ask a question, please? Is the Earth flat? Okay? That's who those people are.
Yeah.
It's not a problem. But eventually someone's going to explain it to them in a way that they do understand, and that they say, yeah, okay, all right, I go along with that, because it makes sense, Eventually they'll get there. Like I said, I think it's pretty crowded at the moment, but it'll shrink to practically nothing, especially once the space tourism happens.
Yeah. We do have some flat earthers in the chat here. A guy named Rich.
I'd love to talk to flat earthers. They're actually more interesting.
Rich Bolton says, in second grade, they teach you the Earth is round. Ha ha, so funny, he says.
Well, I don't know. I think he has to. I think he has to probably define what he means by teach. So is the teacher going to say, yes, the Earth is spherical? The teacher's probably going to say that, and then the teacher's going to add, and this is how we know. Okay, he might have been looking out the window when the teacher did explain how we know. So he only heard the bit, the Earth is spherical.
And I apologize for calling that one question a trolley question. You probably weren't here. I know.
No.
So,
you know, from an educator, we don't have any dumb questions, and there are no trolley questions. Okay.
True. That was my fault. Okay, so I want to show you this, and we can wrap things up. We'll do like a 30-second break or something and wrap things up, or if you do have to go, we can do that. But I want to show you this before we finish. So,
my day.
Okay, well maybe we'll do a little tiny bit more. I don't know. I'd like to talk to the chat a little, but okay.
Yeah, no, let's get some questions. Let's see what they have to say, especially flat earth.
So yeah, we'll jump in the chat and we'll just riff with the chat after we take a 30-second break. Before we do, I've got this screen image I want to show you, and it came from the Nathan Oakley flat Earth debate. And let me share my screen to you so I can get it going, and I'll go full screen here so the audience can see it all nice and big. But okay, So this was.
I can't see it. So what do I have to do? Minimize.
It should be in your Skype.
Oh, hang on. I'll just go to Skype there down here. Yeah. Okay, I got it.
Okay.
I'm having a look at a black screen now. So yeah, with something on it.
I'll read it to you. It's only It's let's see, Sleeping Warriors and Nathan Oakley are DMing on Twitter or somewhere. And what happened was somebody joined the chat and they were talking about a lighthouse. It's kind of a famous thing that happened on the Flat Earth debate a year ago. Okay, so the screenshot was taken by one of the guests, and Nathan Oakley says, "Stop, this is a trap." Sleeping Warrior replies, "Go on." And Nathan Oakley replies, "The lighthouse is 21 miles from the lighthouse, so it's 10 miles away, not 31. It proves the bulge, the globe." And then there's another comment where Nathan Oakley is saying to Sleeping Warrior, "No, it's perfect globe proof." So this was what they do in the background of their Flat Earth debate, and we got a little screenshot of it. So
this is not surprising. Think about it. If you were making a living from this, you would have to be very, very careful. And obviously, they said stuff like this in public, and that's not careful enough. That was pretty dumb.
Yeah. Oh no. Yeah. They broadcasted this out to everybody in the whole thing in the call. So some guy said, "Oh, I'll grab a little screenshot," because I don't think he meant to do it, but anyway.
I doubt it.
It does show that, if Nathan Oakley been running that show for as long as he has, and you hear the way he yells at people and puts them down, to know that he's stopping someone in the background from talking, "Hey, that's globe proof. Stop. It's just interesting, in my opinion.
Exactly, it is. I heard that word "interesting" in a documentary, actually.
Exactly. You caught my reference. Okay, so what we'll do is we'll take a 30-second break because I got to hit the kitchen real quick, and then we're just going to talk to the chat for a little bit, and we'll go offline. So anyway, stay where you are. If you have questions, my mods will grab the questions. They'll put them in a Discord room for me, so we won't miss your stuff. And don't feel bad if you have to repeat a question in chat. So. All right, I'm gonna mute us out really quick, sir. So whenever if you got to grab something too, we'll wait for you. But here we go. Muting out, and we're gonna go ahead and go to the front screen. Don't go anywhere, chat. And if you do want to say anything, start typing. We'll get to it. So here we go. Appreciate everybody being here in the chat. Okay, I've unmuted us. Phil, appreciate you being here again. I want to thank you for coming. Been a great conversation. Hope to have you back soon. So,
no worries.
And Dodger, thanks for joining the channel again, buddy. Appreciate you. All right. So, I'm just going to read through some of the comments here inside of the live chat, and then interrupt me as much as you want. Don't be afraid to interrupt me.
All right. Go for it.
Okay, scrolling up, and we've got, okay, somebody's questioning a flat earther here. So, Phil says, Uni thinks I'm a flurfer. No, I don't. I don't think you're a flurfer, my friend. Don't worry. I don't mind if you are or if you aren't. Hey, I think that it's, we all need to start talking to each other, honestly. So,
yeah.
Yeah, actually, my friend, my assistant is a flat. I have an imaginary assistant. It's a big. It's a thing with my show, but he is a flat earther. So make sure you remember.
Oh,
that,
okay.
Mac.
All right, that's all right. I'll be kind.
Okay, so somebody said this, flat Earth makes me think of Asgard, so if it's flat, wouldn't the oceans drain, right? And what do you think of that? I don't know what Asgard is.
I'm not sure myself, but I think your friend ought to think about those tides that I said. If the water's all gone out over here, where is it? And
Very
therefore,
true.
how can it be flat? How can it be flat if the water's gone from over here and it's piled up over there? How can it be flat?
Yeah, and Rich says again, can I buy a brain from Amazon? Is that where you guys got yours? Yes, it is, Rich.
Yeah, you can actually. It's called books.
Yeah, just order a couple books, buddy.
That's all you
good.
need.
That was a good reply. I like that one. Amber says 60 years of satellites say that the Earth is a spheroid.
You bet. You bet.
And
Absolutely.
Sean comes in. Granted, the way I phrase this is philosophical, but you might even say the evidence makes Earth round a justified true belief. I agree.
Yeah, I think if after 60 years of sending up satellites and then having a look at the telemetry, having a look at the the photographs that come back, look at the PLV polar launches, for instance. 37 is the best one. 37 PLV 37 actually shows you 104 satellites being launched. So they're nano satellites. So they're about a foot, a cubic foot each. They're quite small. So many of them sent by universities and that as little experimental things, and 104 of them in one payload. And you can actually see because these are spring loaded. So what happens in the once the fairings are gone? So the fairings are the covering, if you like, around the payload. That's discarded earlier on in the piece. So once they reach the transit orbit that they're going to go to, then a spring-loaded mechanism actually shoots the satellite away from the craft. So, and as each one gets flung away, you can actually see it going off into the distance. Obviously the image is not that great. It's not like 4K, because you imagine we've got to get this signal back to Earth, in real time. So that wouldn't happen if it was a signal as much as 4K. But it's enough for you to have a look, and you can see how amazing it is to watch these satellites being deployed, when the spring lets them go and they actually get deployed. Have a look up C-37, so polar satellite C-37. I think you'll find that fascinating.
Yeah, definitely. We've got Chris Chandler saying, if the sun was local, what could it be made of? As in, its current form, wouldn't we get severe radiation and UV issues?
Wow, that's an understatement. So the sun, this isn't something that we imagine. We imagine the sun is giving off X-rays. We imagine the sun is giving off gamma rays. I mean, these are very, very dangerous rays to us. And thankfully for Earth's magnetic field, we don't get the full brunt of that. But we do get some radiation. Particularly, we do get UV. So in our country, where the ozone layer is depleted, we have the highest incidence of skin cancer in the world. And this is because of the UV radiation that's passing through the atmosphere. Up in Europe, where there's a blanket of ozone, it's not so bad. But over here, it's pretty bad. So we can measure this radiation. We have instruments that look at it, can measure the wavelength, can measure its speed, you name it. We use it. It's called spectroscopy. Mm-hmm. Okay, we can have a look at the lines. We can have a look at the radial lines. We can tell one element from another using this method. And we look up there and we say, wow, okay, the thing is predominantly hydrogen, and then we have helium. And then we model that, and we look and we say, well, this is a fusion reaction. So hydrogen protons are being smashed together to create helium. And as a result, producing this tremendous amount of energy. This energy comes in an electromagnetic spectrum, all the way from at the short end from gamma rays, all the way at the long end to radio waves. And right there, a small slither of it is called visible light. In between infrared and in between UVA. This invisible light, this visible light is exactly what we see. This is all we see. If we were animals, we'd see a little bit more. When I say we are animals, but if we were, cats and dogs, we'd see a bit more. But this visible light is just a small part of this electromagnetic spectrum that comes from the sun. Most of it, thankfully, is deflected by Earth's magnetic field.
Yeah, great point. Whoever made that point, it was a great point. Oh, this is a good one. I have a quick answer for this too, and then you can correct me if I'm wrong. Roxy says, if you drilled a hole all the way through the Earth so that you could jump in it, would you stop falling halfway due to gravity on the other side? I think you'd be crushed before you got even close to the center, but what would happen to us if we did jump in a hole?
Okay, that's an excellent question. It's a great thought experiment. By the way, Einstein called that a Gedanken, which means thought. Yeah, Gedanken. Okay, so let's have a look at this Gedanken. First of all, we'd have to establish where Earth's center of mass is still. So changing things can change the center of mass. So where things will fall will depend on its center of mass. So that could change by the nature of how you change the actual massiveness, if you like, of the Earth. So if you did fall down, then you'd get to, you'd definitely be crushed, I would say, by the time you got halfway. The question would you get out all the way? Would you fall all the way through? That is an interesting argument. I don't think so. If we go by the gravitational theory, no, you wouldn't. So you'll be stuck in the middle.
Okay.
Yep.
Yeah, I know that gravity, out by Jupiter, molds the moons a little bit and forms them, causes like volcanic activity on some of them, and I could just imagine it'd be kind of hell on the body to jump through the Earth like that. But I don't know.
Well, put it this way: if you again, what you've got to consider is what the forces will be. So, is which way will gravity be pulling you if you were jumping in a hole? That would be the question. The question you could ask, and I could be wrong about my previous answer, because you could ask where would gravity be? Remember, you're falling through F equals mg. So where is this g? That's the question if there is a hole. I think it's not an easy question like that. I would have to give it a bit more, actually. However, if you're on the outside of it, and I often try to get people to understand how this works. Let's say, for instance, you're on the outside and you're some massive giant, say one of those giants that used to exist according to some flat Earth, and you could kick a ball. Yes. And if you kicked this ball, but you just couldn't kick it far enough, you could imagine the ball would come down, would fall back on the Earth, wouldn't it? Some distance away, but it would still fall. All right, so let's say you decided to kick it even harder, still not enough. The ball still falls down to the Earth. And the third time you think, well, I'm really going to give this a whack. So you kick it really, really hard, but this time you kick it so hard, it doesn't fall. It keeps falling, but it's going so fast, it can't fall back to the Earth. That is what an orbit is.
Yeah. Oh, yeah.
You've kicked it so hard, it can't come back. So in other words, it keeps going round and round and round. Maybe they ought to watch some old Superman movies. Yeah.
Oh, yeah. That's a good, the end of the one where he's reversing time and everything. That tripped me out back when I was a kid.
There's there's a fair bit of physics in some of those movies, and it's quite amusing actually, and how they put it together. And if you thought about it, the people who actually thought about that script did understand a little bit about the physics, which is fantastic.
That would be a good YouTube video.
Yeah,
I'm gonna have to look at that.
Yeah,
the physics of Superman.
Yeah, exactly. Yeah,
time.
No, that's good. Well, it's Superman's is affected by kryptonite. Well, there can't be a mineral called krypton is one of the noble gases, right? So, which by the way happens to I believe it is if you excite the atoms, looks green.
Huh.
So it wasn't by accident that they decided.
Oh, okay.
That. Yeah. So although it can't be a mineral, obviously, because one of the things about the noble gases is the difficulty with reacting with any other elements.
Well, there's a question, but I don't know what Smack is trying to say. Maybe you will. He says, do you know that water in relation to climate change? Okay, got it out. In relation to climate change, do you know that water vapor is over 200 times the greenhouse gas as CO2 according to concentration in atmosphere and specific heat? Long sentence, messed me up reading it, but I don't know what he was asking.
No, I get exactly what they're saying, okay. And yes, water vapor is one of the greenhouse gases.
Okay.
Yeah. When no one's disputing that. However, it's water vapor will eventually coalesce, and it's nothing like what the problems that we would have from CO2, for instance, and CH4.
Well, Negative Exponents asks a great question, and I know exactly what he's talking about, so I'm going to add to it. Can you get his thoughts on man-made objects if he thinks science is strictly for naturally occurring objects like trees? So what he's asking is, there's a big argument in the Flat Earth debate that a shoe is not a natural object, or I'm sorry, not a natural object. I'm missing the term they are using, but, well, I guess I need it for this question, but, okay, maybe Negative Exponents will help me, but the big argument about, is a shoe considered, natural because it's made out of leather and all this. I might be I'm saying it completely wrong. Someone will put it in the chat though, and then I'll get it right after they do. But
okay, I don't know how I could answer that, but the components of the shoe are definitely natural. But what put the shoe together? Obviously that was done by human. Well, we would say that obviously it would, because you've got to think about this and say, let's say we had that time was infinite, and I'm not saying it is, right? But let's say time was infinite. What are the chances are that a shoe could just appear? All the things get together so that a shoe could appear. You could ask yourself. Okay. Yeah, it's a bit like it's just like the watchmaker thing in the religious argument. You'd put that at zero probability, almost. But you couldn't absolutely say zero probability, could you?
Oh, we got a good one here. I got to find it. Okay, In His Image is getting a lot of blowback from people. I want to find his question here.
Sure.
If somebody knows what In His Image asked, I'm sure one of you guys do. Type it out for me, but I'm going to have to skip it. It's way far up there, I suppose. Okay, now, here we go. I'm getting close to some. Okay, well, never mind on that one, but... Okay, somebody said, Busted Shark said, In His Image, referring to another live chat participant, you're not sorry and your assertion is fake. Facts don't care what you think. Ignoring them will not make them go away. I really want to know what In His Image said. Okay.
Well, that answer was perfect.
Yeah, that was a great response, whatever he asked, I'm sure. So, okay, here's one. In your experience in India, Asia in general, is Flat Earth a Western issue, or are we missing some awesome non-English speaking context?
As much as the Flat Earth people would like to think that Flat Earth goes around the globe, I meant that. It doesn't. It's pretty much a Western stuff. I don't know anybody. If I said that to some of my Indian counterparts, in fact, I have, and they laughed about it. So,
well, here's a great question.
Nobody. I don't think there'd be many people in India who think the Earth is flat.
Yeah. Okay, so here we go, and I'm so glad that there's a flat earther in the audience. I'm so glad he made this point. He said, all of the pictures, your GPS, your satellite TV, are all fake. That's what he just said to us.
He'd like to believe that. So I will say, go to the polar satellite images like C-37. Have a look at some of the videos. All right. Have a look at the videos. Look up call up videos. There's some amazing stuff. Let's see. See if you can don't just look at the images. See if you can find some videos. That's the PSLV C-37.
Oh, I found it. Here we go. Got it.
Yeah, that's one of the beautiful ones. Yeah.
We'll let it play in the background here while we talk.
Long ago. That was just in February, a couple of years ago.
Oh, wow. Oh, yeah.
There you go.
Okay, and then
Now, that's the real stuff. That's the real stuff.
Oh, those are the satellites.
Yes.
Coming out.
Look at and the blue thing. You know what's that great big blue thing alongside it? That's our beautiful planet. Okay, that's what it looks like when you release the satellites. Look at them go.
It's just amazing.
It is amazing. It is fantastic. You know, so for silly people to say, "Oh, this is CGI," you're missing out on so much. You're throwing a chance to be excited. You know, about this is the cutting edge of science.
Or even participate, for God's sake. I mean, you could figure something out and submit it to everyone, and even a thought you have could be the thing that changes something, you know?
Yeah, have a look at them. Have a look at it. It's absolutely amazing. And this particular camera was actually fitted in the payload. So these things become apparent as soon as the fairings were ditched. So the fairings, what happens is each bolt is like a small explosion. So it practically explodes off two sides. It's like like a cocoon that's split down and just splits apart.
What kind of data do they collect?
Oh, look.
What do they do?
All right. So the polar satellites generally would be Earth observation. So many polar satellites are military focus. And what happens is the satellite travels pole to pole. So they would leave near Chennai. They would leave. They'd head south somewhere near Australia, and they would head south towards the South Pole, and then they'd keep in that particular trajectory. And the idea is that the Earth spinning below the satellite means that the satellite gets to see the entire Earth in 12 hours.
Oh, wow.
And it's close enough, and remember, we're talking about military now, it's close enough so that they can spot some very, very small things on the ground.
Ah.
All right? So there's a lot of stuff that you know, people in the satellite industry can discuss because, you know, like this particular thing is published, but there's so much that's not published for obvious reasons.
Well, I've got a point to make. So in a minute, you'll see it if you're watching or you might be looking at my screen, but if you're watching the replay,
I can see that the Earth and half of it's in the darkness. Yeah.
Okay, so this is called Space Engine, and I spend a lot of time in it. It's basically a perfect model of our solar system, and then it's an algorithmic model of our universe. So you can fly to any planet, any star system, any, you know, whatever. So one thing that flat earthers always say is that every one of our images are fake. Now, can you talk about what you know about how much, you know, there's a lot less light as we get towards Jupiter. There's even less light towards Pluto, you know, because the sun gets so small. Can you talk about how they take the images, or you know, how they see so much in such darkness, and maybe just add a little to that?
Okay, well, there's a number of ways of taking images. One would be, remember I spoke about the electromagnetic spectrum. Okay,
Mm-hmm.
There's visible light, and there's those radio. There's ways beyond that. They are all actually the same stuff. Okay, so when we say we take a photograph of something, let's say you take a photograph in infrared. Okay, that doesn't mean you're not using light. It just means you're not using visible light. Okay, it's still the same stuff. And on the far end of the spectrum, you get radio and microwave. On the other end of the spectrum, you get gamma rays. But we are talking about the same stuff, just different wavelengths. So when you talk about photography doesn't necessarily mean with visible light. Okay, it could mean using radio waves. So, and that's how many of these objects that are so far away that visible light isn't a useful option will use radio waves or microwaves or other parts of the electromagnetic spectrum. But they all are the same stuff. Okay, so I think this is probably the point that's not understood by flat Earth people, or well, probably most people.
So if I were to go into a cave where there's no light whatsoever, and I took pictures of myself with all these different methods, you'd be able to see me, correct?
Absolutely. Well, if you went into the cave with your cat in the dark, your cat would see you.
Yeah. So obviously, a flat earther who denies images that are taken like this, I think they should go into a cave sometime and go spelunking a little bit, and then get some images taken of themselves, and then look at them so they can say, wow, these images aren't fake, because obviously I can image myself the same way, and maybe they'll correlate how we image these things out in the depths of space, you know.
How do they imagine an infrared camera works? How do they imagine it works?
They just think that, like, all the pictures of Saturn, all the video of Saturn, they think it's all fake. And you can get, I mean, one thing I did a couple weeks ago, I took a telescope of Saturn, now not an observatory. I took a regular telescope from a person, really expensive one, grabbed the video footage of it, and then I compared it to what Saturn looks like to show them, like, hey, this is a probe that went by in 92 or 86 or whatever it was, and here's the telescope image. They're not fake. These are obviously things in the sky. I'm trying to get that point to be made, but it failed, of course.
Yeah, naturally. So I think it comes down to probably a misunderstanding about what light is and what this electromagnetic spectrum is. In fact, I hear that word used a lot, electromagnetics, and they talk about electromagnetics as though that's some amazing way that the sun can move around. Hang on a second. You at least get the words right. So when we talk about the electromagnetic spectrum, we are talking about light. We're talking about waves. We're talking about photons. Okay, so at least get that right. So they obviously thinking about magnetism and confusing the electromagnetic spectrum with magnetism. Okay, these are different things.
That.
Yeah, exactly. So these are quite different things. And so I guess if they just tried to learn a little bit about physics and the physics of light, that would be pretty self-evident.
So on my screen right now, I'm going to hit play, and this is me inside my universe simulator turning up the magnitude so that I can see more stars. And I turn it up so bright that it almost makes a wall of light. And I'm hoping some flat earthers in the audience will see that this is what we would see if we could, see all the dots of lights out there.
Yeah, exactly. In fact, flat earthers can watch satellites this way. Okay. In other words, use a long exposure. For instance, face it towards the either you can face towards the equator, where the geostationary satellites are, or you can face it towards the poles. This is where around about 5 degrees, this is where the polar satellites are going. Now, if you leave a long enough exposure, you will see that there'll be sufficient light will come to the camera and you will be able to actually see the satellite, and you'll see the streak of the satellite. And it's always consistent. Now, if you care about what you think, you must ask yourself the question, what's happening up there? Why is it that what they say about satellites comports exactly with what I see? It's like saying, there's the ISS. They're saying this thing is a fake, and yet they're quite happy to have a look at this as it goes past the moon and see it. It's the shape that you expect it to be, because you can actually see the wings that grab that the solar panels are on. You can actually see it's shaped like an H. And then you look at the picture of it, and it looks like an H, and there it is going past there. You can't deny that it's going there. You can't deny its shape, and yet you deny that it's up there. You think that's some magic thing that's up there. We don't know what it is, they say. Well, how come we know that it looks like an H? How come we know when we actually look at the thing, it looks like an H? You know that old thing about ducks? Walks like a duck, quacks like a duck, is a duck.
Oh, yeah.
Well, come on.
I want to ask. Oh, go ahead. Sorry, sir.
It's all right.
I want to ask the audience really quick, if you will please type some arguments that you hear popular flat earthers using, if anyone can, before we round out. So, because I'd like to bring up some of them. I know one argument that we've already hit, the Einstein argument from Sleeping Warrior. I could never stress their use of semantics enough. I don't know if you want to touch on it at all, but
yeah, look,
thing, the way they argue and how they take the argument, and they don't care what we're saying. They just want to manipulate the words. What can you speak to about that?
Okay, so this is the classic deflection. Okay, it's used a lot by politicians. I ask you a question, and you answer with a question you would have liked me to ask you. Okay, so that's one way. The other way is the deflection is this. I try to discredit your question, not even your answer, not even your idea. I try to discredit your question by saying that this is not the current science. So you've got no right to ask me that question. Okay, you've got no right to ask me how come the sun goes around, because your question is not based in science. Your question doesn't wiggle the independent variable. Okay, so this is how they deflect. So they use semantics. They say they use they twist words. They use semantics to deflect away from the actual bones of the question. Okay, and they must do that. They're obligated to do that, and I understand why. Because if they answer the question, then they put in jeopardy their money, and that's basically it. So here comes somebody like me who has no interest in making money from YouTube, mucking it up for them. So here I am on your show, giving out some facts, and I'm doing nothing for them, for their source of income. I'm damaging their source of income. Of course they're going to be upset, and of course if you address them personally, they will deflect to semantics. They have to.
Yes, and you're very, very much correct. And Negative just brought up some great stuff, like they say that we don't live on a model. Mathematics can't be used in science. Arguing from fallacy. Science must be a cause and effect relationship only. And you can speak to that. You've been participating in science your entire life. So what do you have to say about those arguments?
Okay, that's actually, that is a very, very good question from the flat Earth point of view, and that is this misunderstanding about what science actually is and why we do it. So what we're saying is, all right, let me give you the example of the Navy shooting a ballistic missile. Okay, so Newton comes up with a model that says if you shoot a missile at a particular angle at 30 degrees, let's say, it will rise to a given height which matches a parabolic motion and will end up at a certain distance away. All of this is predictable. In other words, I know exactly if I have a starting velocity, I know exactly how high it will reach, and I know exactly how far it will go, and I know exactly the direction it is. This is really important because in the barrel of this gun is a $5 million missile. So I can't be guessing these things. So this equation is called a model. So I use this model now for all sorts of ballistics where I need to be able to shoot a ballistic missile. Now I say, well, what if I extend it so that the velocity that I shoot this missile is enough to overcome the downward vector of gravity? What would happen? Well, it's like the giant kicking the ball. If I can overcome the gravity, then this missile is going to continue. That missile will then go into orbit. It will keep going around the Earth. It'll keep missing the Earth. It's falling, but it's missing the Earth. Now we have an orbit. This is what an orbit is. It's just falling and missing the Earth. We are falling around the sun. We're just missing it. Now, as I said, I'm happy to do this description with Newton and Einstein, and I'll show you how falling around the sun, how an ellipse falling around the sun is actually akin to going in a straight line. It is the best way to move. It is the most efficient way to move. To all the world, looks like to us going in orbit, but in fact, the physics of it is that it's going in a straight line. I'll show that to you, how that works. It is fascinating.
Oh, I can't wait. I love that kind of thing. And right now, there's so much that's being kind of muddled and I don't want to say it's being destroyed, but you know, some of the arguments they have on the Flat Earth Debate and these other shows completely, tear apart some of these facts that can be proven. You know, models, you can't say that a model can't be used. If you can use the model to say where a bullet's going to land every time, how are you going to say that it doesn't apply to reality? It's insanity.
Exactly right. So that's not the only model. There's for instance, Kepler came up with the equation with the constant, which is r cubed over t squared. So r cubed over t, which means that the cube of the radius between the two bodies divided by the square of the time it takes for it to go around, is precisely how we decide where to put the satellite. In other words, a geostationary satellite has to be able to go around, to orbit in exactly the same time as the Earth goes around, so that it'll stay in the same place. This is critical. So it has to be a critical distance from the Earth in order to do that. Now, if you put it further away, like say that's at 36,000 kilometers, let's say for instance you put it at 40,000 kilometers, it will go slower. This is in fact at 40,000 kilometers what we call the graveyard orbit. So those satellites where they're no longer used are then sent to a graveyard orbit, which is about 40,000 kilometers away, which is away from where anyone would need it. Okay, so that we can take a satellite out of geostationary orbit to 36,000, put it in a graveyard orbit. Nothing's going to bump into it there, and if they did, we couldn't care less anyway, right? Because that's just the junk that's there. And open up.
Burn if it comes into the atmosphere.
No, never come back.
Oh, it could never come back there.
No,
okay.
It's 40,000 kilometers away. It may go somewhere else, but it won't be coming back to Earth. Okay, it's the moon, for instance, is moving away from us. The moon moves away about in the American vernacular about 4 inches a year. It's moving away, and we know
it'll take a very long time to float away.
Yeah, it will take a long. But you know, this is the irony about it. So the flat Earth, one of their first conspiracy things is they say nobody went to the moon. Okay, so that's what they say. Well, you know, there's 4 retroreflectors on the moon. Actually, there's 5. One of them just crashed three Saturdays ago. Okay, unfortunately, on the Indian lunar lander, there was actually a brand new retro reflector. So this is like having a mirror, okay, only a very sophisticated mirror. There's actually 4 of them on the moon right now. There's one of them I don't believe is in service any longer, but number 2, the one that was put there by Apollo 70s, is certainly in service. Now that is used. That we can determine that by a pulsating beam, that laser beam that lands on that retro reflector and then comes back to Earth, and we can measure that. So we know that it is the right one because we know what wavelength we used. We know the speed of it. We know the wavelength we used, so we know that we've got the beam back again. Okay, all right. So that then is used, if you like, to be able to measure how far a satellite is. How else would we know how far the satellite is? We know its precision. We know that it's 36,000 kilometers within a very, very high level of precision because we can actually bounce a laser off it. Okay. Otherwise, how else would we know? So this is an important tool, and the retro reflector's up there. How did it get there? Is this another one of those magic things? So I've heard some flat earth people say, well, you know, back since in the 1950s, they were doing experiments with trying to get a laser to bounce off the moon. That's true. But there's no way known that wouldn't scatter. So yes, you can try and bounce. Yes, you might be able to see some signals, but you couldn't count on any kind of precision. That's the issue. The only way to get precision was to get a mirror up there. In other words, a retro reflector.
And it's funny, they try to come back with anything they can to discredit anything. It's just instant. But that's good because it gives us a chance to explain it to them. So here's another really great point.
Sure.
You can't have gas pressure next to a vacuum. That's one of their main things. I know you touched on it lightly earlier, but my goodness.
Let me go over that one again, okay? I love this one, okay? All right, so right down at sea level will be, if you like, the most dense area for the gas. And the gas gets less and less and less and less as you go up. So in other words, there are less and less molecules. Now, some people might say that, well, actually, it's not because there's less molecules that the pressure changes. It's because there's less of it above you that the pressure changes. That's interesting. However, if that was the case and the amount of molecules were the same, you wouldn't need a breathing tank if you were standing on top of Mount Everest. Okay, if the problem wasn't that there wasn't enough oxygen. The reason that you need breathing apparatus on top of Mount Everest is because there are not enough molecules in the atmosphere for you to sustain your life. There's only certain, I think it's about, you need 1.52 moles of oxygen in order for you to be able to breathe properly. So don't quote me on the figures. I actually have this in a lecture. You can actually look at the lecture and you can see I've got the exact figures, how much you need to breathe. And why it is, when you get to top of Mount Everest, there just isn't enough. In fact, I think there's only about a third as much as you need to be able to sustain life. So therefore, you need to take your oxygen with you. Now, this goes more and more. If you're up in a jet and you're 40,000, which is, another third of the height above Mount Everest, so Everest is, say, 29, you're up at 40,000 feet, there's going to be even less. I think you go down to about 0.42 off of moles instead of, what you need is 1.57. You go down to 0.42 moles by the time you get to 40,000 feet. It gets worse and worse the higher up you go. And guess what? This correlates with the fact that it gets colder and colder and colder. In other words, there's less and less heat the higher you go. That is, these molecules are much, much further apart. Okay, fewer of them are banging into each other. Now, if you just keep going, you've got to ask logically, what happens if you just keep going? It gets less and less and less. Finally, it gets to the point where there's very, very few at all. Well, this happens around about 100 kilometers away. We call it space after that, for no other good reason that there's a lot of space in between the molecules, so we call it space. Okay? It just is another area where there's less and less of it. You do not need a barrier in between the atmosphere and space. Now, what's gravity doing? Gravity is holding all of this together. The reason that it stays with the Earth is because of gravity. Gravity at the Earth's surface, and it doesn't change much. The ISS is still not that far from 9.81 meters per second squared in terms of its gravitational field. All of this gas is being held to the Earth. Just like anything, the gas molecules have mass. If they have mass, they want to fall. Everything that has mass falls. Climb up the building and jump. See if you don't fall. Everything that has mass falls. Gas is no different. It has mass. So all of these things now are with the Earth. Now let's just say, for instance, you had a picture and somebody had a ball, and the ball was, let's say it had a diameter of 10 meters. 10 meters, all right? So you work that out in feet, okay? So 33 feet, okay? So we had a 33-foot ball. Well, you pick up a piece of paper. That would be about the thickness of the atmosphere around it. So you think about how thin the atmosphere is compared to the size of the entire Earth. So people say stuff like, well, how come the atmosphere moves with the Earth? If you had something that was clamped around around just about the thickness of a piece of paper compared to 33 feet, you bet it would move together. Of course it would. It would be like if you wet the ball, wouldn't the water still be there? Don't things get wet when you put water on it? Well, why is the water sticking to it? Why doesn't the water just fall off things? Why do we need dryers? That's because there is a propensity for things to stay like that. The gravity is holding all of this atmosphere. It is not like a thick layer of atmosphere and then suddenly space. There's no such thing. This business of saying, how can this exist next to a vacuum? The question is stupid. The question is wrong. I shouldn't say stupid. I take that back. The question is wrong. Because there is no such thing anywhere in the universe. Why should I answer a question about how can a vacuum exist next to a pressure system when there is no such thing? And I agree, there cannot be any such thing. It doesn't exist. There's no need for me to answer that question.
So another great one that goes along with what you're saying is they always talk about, and they think this is their, biggest proof ever. Well, this is the second biggest proof ever. I got the first one coming up. The second law of thermodynamics proves that we must live in a container, and them also another part of it, how much they misrepresent the second law of thermodynamics is pretty big one too.
Okay, all right. So what they're expecting from that is they say, why doesn't the atmosphere leak off into space? That's essentially what the crux of their question is. And the reason for that is I've just mentioned, gravity. Gravity is holding the molecules down. That's one. So you've got to decide, when you look at forces, what is the predominant force? Is it a molecule that leaks off into space? And by the way, they do. Okay, so there are some of these molecules that are that have enough kinetic energy to be able to get out of the gravitational field. So that certainly does happen. So we are losing the atmosphere. We're losing it in such a small amount that it would make nothing to the life of humans on this planet. In other words, it's in the order of millions of years. Now, do we want evidence of something that's actually happened like that? Have a look at Mars. It did once have an atmosphere. but it's lost it. It's lost most of it. It still has the heavier stuff like carbon dioxide and water. It still has that, but it's lost all the other lighter stuff. What is carbon dioxide? For every single mole of carbon dioxide, so let's say at sea level, we're looking at around about, let's say the temperatures today, let's say it's 20 degrees. This is about 24.5 litres for every mole of carbon dioxide. It weighs 44 grams. How do I know this? If I look at the periodic table, I can see that carbon is 12. 2 oxygens, 16 each, that makes 32. Add the 12 to the 32, I get 44 grams for every mole. In 24 litres of this 24.5 litres of gas, I have 1 mole. So therefore, I know how much 1 mole is going to weigh. It weighs 44 grams. Guess what? Oxygen only weighs 32 because there's two molecules of 2 atoms of oxygen together. So of course, carbon dioxide is going to sit below the oxygen. Gravity is going to influence carbon dioxide more than it influences oxygen. Same with nitrogen. Nitrogen's just 28. There's 2 nitrogen atoms together, each of them 14 grams. 14 mass of 14 grams. 2 of them together, 28 grams. Still less than carbon dioxide. You can practically pour carbon dioxide as if it was like a liquid. Okay, and you can actually see people pouring the gas. You can actually see the gas being poured because the condensation allows you to see how that works. I hope that answers that question.
It's great. So now another question along these lines of containers, atmosphere, such things. Why do you think they think that the vacuum of space must suck the... They literally act like it must suck the atmosphere off. Is it because they don't understand what a vacuum is and they're comparing it to a vacuum cleaner, or what are they doing there?
I think that is. I think they think that a vacuum has some sort of power associated with it.
It seems so rudimentary, though. It's like
no,
really
you're
bad.
Right. So let me see if I can explain this. So the vacuum, they think that the vacuum has some sort of power to suck things. Whereas in fact what happens is where there's a space, things will try to fill it rather than the other way around. Okay, so things are more likely to, looking at the laws of thermodynamics, things are more likely to fill something rather than some vacuum sucking things. Now, so at the ground over here, 14.7 pounds per square inch. So in our metrics, we use the metric system, so it'll be 101.3 kilopascals over here. Okay, well, this is not that much. So at 14, so the difference between the very top, if you like, high up there, so 100 kilometers away, and the difference between that and what's at the bottom is only 14.7 pounds per square inch. It is not huge. There is much more difference in the tire in your car. The tire that's attached to your car has many times more pressure than the difference between what's on the Earth and what's 100 kilometers away in space. So to get this idea that there's going to be this great rush of air leaving the Earth, heading towards some, that is nonsense, because that vacuum of space is just the continuation of the amount of gas that's on the planet, on the bottom, that gets less and less and less and less until there's practically none. And what there is there, gravity is holding it together, thankfully.
What about their argument that has to do with if it can't be tested in a laboratory, then it's not science, or then it's not relatable or relevant?
Okay, so we hear that a lot, and many things thankfully can be tested, but some things simply can't. For instance, the guy Henry Cavendish, who had two suspended spheres, and wanted to show that these spheres would be drawn together I mean, that involved a lot of work discounting all the other things that could have affected that experiment. Okay, so having an experiment like that is, for the average layperson, is almost impossible. So even a university lab can show you how these two balls can be attracted to each other. Yes, that's possible, but on the scale that would need to be able to show how, say, water would go around a sphere, you need something as big as the Earth to be able to do that. In fact, even if you had something as big as Mars, you couldn't do it. Okay, you need something as big as the Earth to be able to do it. So someone arguing on Mars would be able to argue that, hang on a second, I've got this great big planet called Mars, why can't you show me there? Sorry, it's not big enough.
What about rockets pushing off of air? It's one thing they try to say, hey, if a rocket's in space, it can't push itself around. There's nothing to push off of. Okay,
so they don't understand. They don't understand the Newton's third law. Okay, which is an equal and opposite reaction, which is the reason that it happens. But let me give you a good example. So most people would know what a bazooka is. I presume they know. I mean, this is I think it's an American weapon. So basically, what happens is that it's just a tube, and in the tube you put your ammunition, and then and there's a trigger, and it fires off your ammunition. So it blows back in one direction. It blows back the exhaust, and then the missile fires from the other direction. So it's like a tube basically, and fires it. Well, it's kind of like that. Is there anything in the back of the tube do they think that the small amount of pressure at the back of the tube would be enough to make this missile go for 3 or 4 miles?
I don't think they even care.
I doubt it. This is the perfect example of Newton's third law. In other words, you fire the explosion. Obviously, the exhaust comes out of one end, but the bullet fires with the amount of force at the other end. Okay, it doesn't require something to press against, okay, for it to go. Now, for instance, hardly anybody ever gets to go to actually see a rocket taking off. Well, if you do go to a rocket pad, let's say before it takes off, the rocket sits on like a platform, and underneath that platform is lots of space. So in other words, it sits on a platform with lots of space underneath it. Okay, all right, and there's openings on this space. So when the rocket starts firing up, the whole idea is to try and get rid of all of this exhaust as quickly as possible with doing the least amount of damage. Because really, a rocket is like a controlled explosion. All right. So we want all of this exhaust to dissipate away. We're not trying to get the exhaust to actually push against anything. We're trying to get rid of the exhaust. It's exactly opposite to what they think. So here we are trying to get rid of the exhaust. Once it reaches space, we don't need it anymore. So normally what would happen is it normally would have 2 or 3 stages, and it would lose, it would burn off one stage. So in other words, there's sufficient energy for it to overcome gravity, has sufficient velocity to be able to get into an orbit, like I said, like the giant kicking the ball hard enough. It's able to do that, and therefore ends up in an orbit. It does not require anything to kick back against in order for it to fire, for it to go. Okay? The act of that explosion itself is the energy that forces something to go one way and something to go in the exact opposite way.
What about this? Now, this one is their number one argument right now, and it's to the point where 2 people, Sleepy, Nathan Oakley, and Quantum Eraser, say it's their destroyer of the globe. Something, Coriolis effect, helicopters. The helicopters should be able to lift up, then they should land in another state if they wanted to, and also they talk about a turnabout and the Coriolis effect, completely butchering the Coriolis effect in the process. Do you have anything you can add on any of that?
Yeah, sure. I would defy any one of them who to jump off a truck, off the back of a truck, moving 100 kilometers an hour, and see if they don't end up, and see if they don't end up going down the road at 100 kilometers an hour as well. So I don't know, about 2 years ago, I haven't ridden my bike for quite a while, but about 2 years ago, I came off the bike on a freeway, right, which was pretty scary. And so I've got a cruiser, you know, and so what happened was this car in front of me decided to brake. I was going around about 100, and there was just nowhere to go. There was traffic both sides. I had nowhere to go. Anyway, I decided that the safest thing to do was to come off the bike. So I let it go. And but you know, lo and behold, I did the thing that physics would expect me to do. I still kept going at 100 kilometers an hour down the road on my leathers, thanks to the leather, of course. And my helmet was completely destroyed. So it just goes to show that my momentum was still there, even though I was no longer on the bike. This is the same thing. Okay, so in other words, just because the helicopter has gone up in the air doesn't mean the helicopter has lost its momentum that it had when it was on the ground. It's quite simple, actually. Now, as far as Coriolis goes, it's obvious. It could not happen like that on a flat plane, because there's no reason for the molecules to be able to move in different directions, which is precisely what happens in Coriolis, which is exactly what you'd expect if the thing was moving. Think about if you're standing on a kid's merry-go-round, okay, and you throw a ball. The ball is going to take a curve. That curve is what you call Coriolis effect. Okay. In other words, it's going to go around, and that doesn't mean that the ball and the roundabout aren't still going. The ball's still moving with the roundabout. It didn't leave the roundabout. It's just moving at a curve because of this Coriolis effect. Right. So that should be enough explanation. I can't imagine what else you'd want.
You're good. No, but my goodness, I just heard it 2 days ago or yesterday, and man, they are getting angry when they describe the Coriolis and other things.
They just don't understand it.
It's the cognitive dissonance. I think they need to believe in the flat Earth, and then when you do start to, if you watch, literally, you can watch flat Earth debate any day and see examples of Dunning-Kruger followed by cognitive dissonance, Dunning-Kruger cognitive dissonance, over and over and over as it goes on.
Yeah.
So we'll just end it out with this last question, or this last
sure.
point. Is a thermos now, like, okay, I get some coffee, I pour the coffee into my thermos, tighten it, close it up. Is it a closed system or an open system? And I'm going to take a chance. I'm going to make myself look dumb, possibly. I consider it an open system because the thermos is constantly losing heat and radiating until the coffee would get cold, regardless of it being in the thermos. Now, they will argue about closed systems, open systems until the cows come home. Am I correct on what I say about the thermos? Am I wrong? Or
no, you're perfectly correct. First of all, there's a couple of things that's going to happen.
Gotcha, Oakley. Sorry, I had to get that.
One is that the cork or the cover that you've got on your thermos, right, cannot be. Remember, nothing touches something perfectly. Okay. In other words, no two surfaces actually touch each other. Now, let me explain that. That is because at the molecule level, at the atomic level, okay, atoms are, if you like, protons in the center, roughly the center of atoms that are surrounded by electrons. There's space there. This space prevents the two protons from touching each other. That will never happen. So if you think about something at the molecular level, at the atomic level, two surfaces never touch each other. Now, when you're looking at a thermos flask, the space, the engineering space that's possible to be made is impossible while it can stop the bulk of air from getting out of it, or the bulk of water or liquid or your coffee, for instance, from getting out of it. It cannot be a perfect seal. So at some stage it will leak. The air was going to leak out of the cork. The heat's going to leak out of the cork. The heat is going to be the heat is also going to radiate out of the sides of the out of the flask. So it's impossible to get something perfect. You get some, lasts 24 hours, your coffee can stay warm for 24 hours, the insulation is fantastic. All it means is that it's slowed down the process, but inevitably it will happen. The heat will dissipate, okay? And cold is just lack of heat, that's all.
And I know I just said that would be the last one, but I just had a thought. Could you do a very, very, very brief explanation of entropy?
Okay, all right.
And I know that's a difficult one, but they get this wrong also. So maybe just
I think it'd be better if you explain to me in what way that. Give me an example.
Okay.
I prefer that.
They say that now I could get wrong what they say. So quantum eraser, if I misrepresent your argument, sorry. They say something about they either say the sun is an entropy machine, or I think that's their argument. Now, I don't know. They could be right there. I'm not saying they're wrong. I'm just saying they say that they use entropy as a reason for I can't even bring it up in my mind right now. Somebody may be able to. We could always ask you next time, though. So
yeah, look, I think the main thing is that this is again a play on semantics.
Yeah.
Okay. So that's it's a deflection and a play on semantics. The fact is, the sun is an object that is in a state of a fusion reactor. So it's a giant fusion reactor, and as a result of that, gives off energy, and this energy is in the form of photons, and this photons is a range from gamma all the way to radio waves, all in between. All we get to see is the visible light. Along with that is heat, which let me raise this other little thing there while we're talking about that, is because what they say is that how can the satellite be up there because it's 2,500 degrees or something like that, what they say, okay? So one of their things is they're saying that it's too hot up there, all right? Well, first of all, you can have a look at on that lecture that I did, you can actually have a look at, I've actually got a graph of the temperature as it goes up towards I think 100 kilometers, so you can actually see what that looks like. But the point is that things get hot. Space is not a place that is hot without things in it. In other words, you need objects that heat is radiated off in order to produce the heat. Okay, now it has other issues, because around all of that is the space trying to remove this heat. So as soon as something gets hot, if you like, there's other forces making it colder by removing that heat. Okay, so I think that's sort of a layperson's way of looking at it. It's a lot more complicated than that, but perhaps next time I'll put a better explanation.
Well, I just want to thank you for coming, Professor Phil. We've been dropping the link to your channel. Any of my peeps out there, please go subscribe. I like what you're doing. I like the fact that that when you approached Sleeping Warrior, that's the first time I saw you talking to him, that you tried to help them. You tried to get them to understand. And now that I've spoken to you, it's so obvious. I'm glad you came to the same conclusion I did. There's a lot of defending their ability to argue so that they can make money. I'm just glad somebody else sees it. Yeah. So
look, if you one thing you can do if you like, and I'm happy to participate. One is that I'll on another show I'll explain how the Newton and Einstein thing works together. But one of the things that would be nice is if you could gather some questions together and then we can do a show where like we spent sort of the last hour or so, I can answer some questions like that that people have. They don't have to be flat earthers. They can just be ordinary people who want some. Imagine that, ordinary people who want who want some answers, in physics, and maybe I'll try to answer in a way that's accessible to most people without adding all the jargon.
Well, I hope so. So thanks for coming, sir. I'll be in contact with you. I'll shoot you an email. And you said you had to do some things coming up in the next couple of days, a trip or something, and some work. So I hope it goes well for you. I'm going to
India in a few days, so there's quite a lot of stuff to do that. And one of those will be to we've got to try and figure out what happened with that crash. And there's quite a number of things that need to be done. I've got a couple of things to sign, and there's a bit of work to do. So I'll be a couple of weeks away.
Well, we hope it goes good, and make sure you keep us updated, and hopefully you can tell us about it when you get back. That'd be excellent.
No worries. I'll try to tape some couple of the lectures that I have over there. It's not so easy because in some places you're not even allowed to bring a mobile phone, let alone record anything. And the only thing that's allowed to be published is stuff that's officially recorded. So that's the other issue. But I'll try to, where I can, I'll try to record one or two lectures.
Great.
And see if I can't explain what happened. Okay?
That'd be excellent, sir. Well, thank you. Talk to you soon.
All right. It's been a pleasure. It's been lots of fun.
Same here.
Again. Okay.
Bye-bye.
No worries. Okay, bye-bye.
Okay, that was Professor Philip Bell, and I really appreciate him coming. I know now, look, you're going to get a lot of flat earthers talking shit in the chat to Professor Bell. Make sure in the future, mods, just kick them out. I'm not going to have it. They want to be, Professor Bell did not have to come give us his time, but they talk shit about me too, constantly, and I try not to kick them for talking shit about me. Like I always tell my mods, you don't have to kick people for talking shit about me. Kick them for talking shit about Professor Bell. Instantly, immediately ban them. Okay, let's go ahead and sum up tonight's show. I'll tell you why I had Professor Phil come, and I'll give a little brief statement. And of course, I'm going to put out, again, I got to remind Dell, Nathan Oakley, Quantum Eraser, Arwen, of my challenge out to them. It's my last video on the channel. And then I'm going to actually tell you why I put out this challenge to those specific people. There's a reason I chose those people. And there's a reason I did not choose Sleeping Warrior. And I will go into all that right now. Though, thank you to everybody that's been here hanging out. You guys are awesome, and the questions you guys put out, even the little bit of banner between some flat earthers and some globers, there's no way a flat earther's walking out of here being honest. This show, being honest and still believing in the flat earth. Not going to happen. You could be in denial. You could be lying to yourself, denial. You could be trolling. Whatevs. Gotcha. You ain't walking out of here, though, laying down to go to sleep tonight without that thought crossing your mind. The earth is not flat. All right, let's do this, y'all. Thanks for being here. We're going to head to an after show on D Live, and let me sum this up. Got a little bit of delay in my webcam. I hope it's not going to freaking fail on me again. The damn thing fails on me every once in a while. I got to get a new webcam. Okay, so Professor Phil was the guy who debated. Didn't really debate anything. He had a discussion with Sleeping Warrior. Sleeping Warrior showed up. And, of course, Professor Phil went first. It was on Ranty's channel. Ranty. Now, I urge any one of you that consider Ranty and Sleeping Warrior and Oakley and these guys, if you support them, I urge you to go watch the show with Professor Phil. Scientist versus Flat Earther. They wouldn't even... Anyway. Okay. So, the reason I tell you to do this is because when I saw this, I saw in the beginning, Professor Phil says to Sleeping Warrior, we're not here to attack each other. I'm actually going to show you what you need to do if you want to be taken seriously, if you don't want to be ridiculed, if you want people like him, professors, scientists, physicists, to take you seriously, and we will, then ask us these questions. Bring us models. Let us help you make the math and put things together and try to show you where you're right and where you're wrong. And we will entertain your flat earth, and we'll test it. We'll help you do it. So imagine this. Out there in the world, while Sleeping Warrior and Nathan Oakley and all these idiots are sitting there on their show playing this act they play to try to make money out of people, religious fundamentalists and others that are just like needing somebody to make the argument for them. A physicist, a professor stands up and says, you know what? I'm going to go in here and I'm going to sit down and I'm going to help them out. And literally what happens as soon as Sleeping Warrior gets to talk, he starts attacking Professor Phil. He tries to bring up his emails. Now, I don't know how Professor Phil telling Sleeping Warrior that Sleeping Warrior is a narcissist, I don't know how that factors into a full hour of the flat earth being horribly debunked to all points that they could ever put out. I don't know how him trying to show that Professor Phil called him a narcissist is valuable there. But what it did show to me is that Sleeping Warrior is the lawyer for Nathan Oakley's version of the flat earth. And he likes making that money. He likes getting the donations. Why they don't try to do something valuable on YouTube, I have no idea. I don't know. Maybe they're just not talented enough. I don't know what it is. Maybe they just know how easy it is to be able to get an in into flat earth. You get subs pretty quick if you do it right. Maybe that's what, I don't know. But once I saw Sleeping Warrior attack Professor Phil, while Professor Phil gave this giant thing like, we're not attacking each other, you have to explain this science, you've got to explain this, you've got to explain this, and every point Professor Phil made was true and on point. For Sleeping Warrior to not, you want to talk to Professor Phil about how he called you a narcissist. Do it after you respond to all these points. If you take Flat Earth seriously. Not only did it expose Sleeping Warrior, but this video exposed the viewer. It exposed the donators. It exposed the people that support these people. It showed that they don't even demand this from their own priest. Because that's what Sleeping Warrior is. He's a priest. That's what Nathan Oakley is. He's a priest. Got me? Now, I had no clue Professor Phil was going to come in here and put Dell up on the screen and say that he thought that people over 40, including Dell and some others who do this, excluding Bob. I don't know how old Bob is, but excluding him from that equation. I didn't know he was going to talk about how Dell seems to be genuine, but I had that same feeling myself. I do think Dell really does believe in this, and he's been duped by, these priests into following this flat religion, the flat church, as I call it. Where am I going with this? I'm just basically saying I finally had figured out this whole thing at that point. You get me? There's a point where you look into a conspiracy theory, an alternative science, something that's going on out there like the miracle solution and all the stuff that goes on. There's a point where you start to understand it. And then once you get that perspective and look at it, you start the puzzle pieces make sense. It's almost like a reverse conspiracy. It's like figuring one out and then being able to identify what's really going on. Well, in the long run, I realized myself that they will not even try to explain the night and day cycle with the Terminator line. The Terminator line is the most important part, being that it cuts the earth like a knife right in half, night and day. And on a flat earth, it is literally impossible to explain the Terminator line. I don't know how they're going to do it. They can't do it. And the fact that they won't do it after all these years of collecting donations to sit on their show and have these fake-ass Jerry Springer debates on Nathan Oakley's show, it really adds more proof. There's more proof that Nathan Oakley is a faker than there is for the flat earth that he's faking. But Oakley isn't just a faker. He's not just a charlatan that takes money selling snake oil. He's also... Actually, you know what? Before I go into that, I'm going to save it for another day because I got an entire video I'm working on. And I might just do it for every flat earther and then every other, I do red pill to pay the bills, and I did that to showing you somebody who was making money by pushing the red pill, and then giving you all these facts about them that shows how they're just lying to you and manipulating to get money out of the situation, right? Well, I'm going to start doing that for the flat earth. It's going to be like red pill to pay the bills, but for the flat earth. And we're starting with Nathan Oakley. We've been collecting pieces of his flat earth debates for almost a month now so that I could put this together. And I've got him fully figured out. And I'm glad I got to show Professor Phil this. I put it in my last video, too. I put it at the end, though, because I know it's going to piss him off. And I think Nathan Oakley will realize he'll figure me out. You get me? Once he gets to the end of my video that I put up before this one that shows this. But I want to show this again because this is... I know there are some flat earthers watching. This is Nathan Oakley. These are the others. I'll read the super chat in just a minute. Well, I'll read it now. I told myself 20 max on supers tonight. I spent 19 on DP, breaking my rule. Called my landlord civil court bluff. Feeling spiffy tonight. Cheers. Thanks, my friend. And hey, don't ever push yourself too far when it comes to that, man. I'll get by. Thank you, though, my friend. Thank you. Appreciate you very much. Can't get by without you. Okay. This is a picture that Cat Earth took. You know why Nathan Oakley, ironically, he always has a picture of, windmills or those wind turbines. And those wind turbines, by the way, that picture proves the globe earth. I personally think he's trying to rub it in the face of the people that donate to him like, ha, here's wind turbines. It proves the globe earth, and I'm putting it on my screen. But he has that up there so that you can't see his screen. But some of his people on his panel could one day. And this is what they saw. They saw Sleeping Warrior and Nathan Oakley discussing how they had to stop talking about a certain thing that Cat Earth brought up because it proved the bulge. It proved the curve. It proves the globe. This is what they are provably. So you may say to yourself, why? I heard Dell yesterday. Dell was saying, why do these people feel like they need to make videos debunking us? Well, I don't know why people did it before yesterday, Dell. Maybe they did it before yesterday because of how much you lose when you take the easy way out of life. How much you're being deprived of. And then, I don't know. Maybe there's a million reasons, but I'm going to tell you this. After you see this, you've got a great reason to try to expose Nathan Oakley. You've got a great reason to call out Sleeping Warrior. They are the literal flat earth definition of the word shills. Literally. This is them saying, hey, we know what the globe is. We get the globe. But why are they arguing constantly? These semantic, crazy arguments. It's to protect their grift. It's to protect the cash. So what are they doing to the viewer? They are taking money deceptively. They are literally defrauding the viewer who sends them super chats, which is why he does his show every single day, twice a day. They are defrauding them. He believes in the globe. He doesn't believe in it. He knows it. It's just a fact. You get me? It's just a fact. That's the truth for Sleeping Warrior and Nathan Oakley, because they were the ones having this conversation. What about Arwen? Yeah, I think Arwen, he's either incredibly brain damaged or else he just doesn't. He's also one of them. He's just really slow, or he's one of them. One of them being defrauding the viewer for super chats and attention. One thing, though, also Professor Phil showed was the triangle, because it completely explains it. The viewer gets hooked in. The viewer wants to also be like those people. How many more of them are going to have those screenshots come out? How many more of them are going to be shown, going to be proven to be fake? You get me? Like I said, I don't think Dell will be. I think Dell one day is going to be a Glober, and he's going to delete his channel and try to hide from the fact that he did this, you know, for the sake of his family or something. I don't know. He's going to say like, oh my God, I don't want anyone getting online and seeing what I argued here for all this time. I should have been able to get this easy. What about Oakley? What about Sleeping Warrior? They are always going to do this. Until the day the super chats dry up, they're always going to do this. Guaranteed. If they make $100, they're just going to start doing shorter shows. The Morgile himself, and then I'll shut up and I'm going to go to the after show. The Morgile did a stream I showed you the other day where his wife is telling the entire audience what he does. It's in this video. All the drugs he does, all the things he's hooked on, the names of the people he buys it from. His wife is, look, there she is. There's the arm of his wife screaming it into him on his channel. Because he knows if he deletes this, he wants people to think that he doesn't care that it's up there. He wants people to think that his wife went crazy and he left it up there. But he's sitting here talking about Anchor What Antiquitech, the Morgile. Let's take a quick look real quick. I just want to show you something. He's got only 89 thumbs up. That's 89 people that saw his wife tell them the names of the people that he buys the stuff from and all those different things that she said. They still support him though, right? Let's find some good comments. Let's see what they say. Been there, mind-boggling. Nice to have you back with content. So low sound, almost impossible to hear. Good to have you back, Morgile. Martin was and will be the liar, no loss there. Morgile, thanks so much for your continued support of knowledge and truth for the people. Love you, brother. He's just a dude that wants his next hit, and he wants to get it by talking about antiquity and mud flood and flat earth. And there's a lot of people out there who want the flat earth and want people to talk about it so much that they're willing to support his next hit because of it. Because they know it. There's just no way around it. It's the truth. The truth of it is, these people will always have a few people that support them. You get me? But you don't have to. You don't have to be conned. All you need to do is go out there and do a search. Nathan Oakley exposed. The Morgile exposed. Just do a couple searches, right? Every YouTuber is going to have a billion videos made on him. What's the difference with Oakley? There's hard proof that he's lying. What's the difference with Morgile? There's hard proof that he's only doing this for drug money. You get me? Sure, you might find the PewDiePie, you know, somebody that just plays video games and they have a bunch of hate videos on him. They're not going to have any hard proof in it. You get hard proof from those guys. And then the last one, I won't even bring up because you know who I want to bring up, who I want to call out, but I'm not going to. Just bring down the show. So thank you for watching. I'm going to go to dlive.tv/UNIRock Live. We are partnered with DLive, which means that we get transcoding. It just means that if you watch us, you're not going to buffer because you can select 480p, you can select 720p, you can select 1080, whatever works for your signal. And some of the streaming sites don't give that. That's why you buffer there. You're not going to buffer with me. I'm partnered with DLive. So come over and hang out for the after show. We do a lot of fun stuff. You know, all that video that I was showing you that I recorded of the different planets and the different moons orbiting them and different galaxies. All of that, we record all the footage we have over on DLive. We just have really good after shows. We watch videos that, we watch videos there, you know. We just have a great time. So if you want to come hang out, if you're ever bored and there's nothing to do on the internet, head over to DLive and see if we're streaming. So we just might be there. Oh, one thing, though, before I start rolling out of here. DLive does play replays for us. So you'll know when we're online. If you see me streaming and there's only a few people there and it'll say, it'll say replay at the top, you know I'm not there. I'm not ignoring you. It's just a replay is playing. Thank you for watching. I appreciate all of you. Thanks to my members because I can't do this without you, the people that join my channel. I love you. You make it possible. Thanks for Vinegar for donating. Thanks to Dodger for re-upping on the channel, rejoining the channel today. Thank you to Joanna, one of my members that's in the chat. I'm going to shout you my members out while we roll out. Appreciate you guys so much. Thanks to George. Love having you. Thank you, Demonic Davros. Good to see you. Neej, good to see you. War. Everybody. My chat just skipped on me. D-Nice, good to see you, buddy. One more thing. Listen. I get it. We all have different opinions about climate change. We all have different opinions about God. We have different opinions about politics, okay? And I appreciate those of you that think that it's right and those of you that think that it's not, okay? We can have conversations and evidence and presentations on that some other day. You already know how I feel. I'm not really educated in it. I feel like there are scientists, there are people out there that argue both sides right now, and it's a very divisive thing and a very strange thing right now to try to understand. I'll speak on it sometime. I'll do a full video. I'm definitely not going to try to give anything right now other than that because I won't be able to say it right. I won't be able to get enough out. I'll promise you an edited video on how I feel about climate change sometime in the future. But I just appreciate everybody for being able to be cool and move forward. And you know what? So what? Some of you believe in certain things hardcore. Some of you don't. The truth of the matter is, though, the video tonight was a debunk slam dunk. And I forgot the most important thing. Let me grab it. I'm sorry. Should have said this before I told y'all to go to D Live. I'm a dummy. Over on my channel, I put out a challenge to several people. I put out a challenge to Nathan Oakley, Arwen, Quantum Eraser, and Dell. I was going to put Sleeping Warrior in as someone for the challenge, but Sleeping Warrior is dishonest. He's rude. He's disgusting. So is Oakley, but Sleeping Warrior, after the last two things he did, well, three. One, he lied about the egg experiment. Two, Bob the science guy debunked him and called him out on that. He didn't even freaking test for buoyancy. He was testing for something completely different and didn't even know it. That's how dumb he dude is. So no, I'm not including him in the challenge. Two, he did what he did to Professor Phil, which was just disgusting. Why waste the guy's time? Why play that little game? Why be a little, soy boy like that? Like, oh my God, you called me a narcissist. I'm not going to talk about all this debunk you just threw out on me. And then I would go into more on Sleeping Warrior, but no, I don't care what Sleeping Warrior says. He can just F off. Oakley, Arwen, Huey, they're almost as bad as Sleeping Warrior, but anyway, hopefully they'll try to put together what the challenge in this video and submit it to the debunking community. And then I put in Dell. I purposely put in Dell. I wanted to put in one person who I thought would actually care enough about what they're doing to try and respond with this. Because Dell, Oakley, you guys, it's not just me that not feels, not believes, but knows that you have to do this before you get to argue Coriolis or gravity or whatever, droppity or uppity or leftity and rightity. Everyone out there knows you've got to explain the most basic thing, because where it sits now, you can argue Coriolis to the cows come home and say Coriolis proves flat Earth. You can argue all the things you argue. But the truth is, there's no way for the sun and the moon and the earth to work if it's flat because of the Terminator line and half of it being in day and half of it being in night. There is no explanation. I've tried to find it. I've literally went out and tried to find the explanation for the day-night cycle with the Terminator line on a flat plane, and it doesn't work no matter how you draw it, no matter how you do it, it doesn't work. It's freaking impossible. It doesn't work if the sun's 90 million miles away. It doesn't matter if the sun's a mile away or 4,000 or 9,000 or 100,000. It just doesn't matter. It doesn't work. It doesn't work when you compare it to our observable reality. And you're going to tell me you can make an argument about Coriolis? You're going to tell me you can make an argument about anything else in relation to the flat Earth? I can debunk you just with that. There it is. Bam, you're done. So instead of wasting your time, which Oakley, Quantum Eraser, and Arwen will do because they specifically ignore anything that will prove or disprove anything so that they can argue semantics and take money from the community. Dell, though, just like Professor Phil said, I think Dell is an honest dude after hearing him talk enough to say to himself, that's right, we do need to do that if we want to continue this. So maybe he'll be the one. Maybe not. Maybe it'll be some other flat earther. Either way, hopefully somebody will start submitting this challenge. I think they took the challenge. I think some people out there took the challenge, and I think they've realized, oh my God, I can't explain night and day in the Terminator line on a flat earth. And I think instead of making a video and admitting that that it's done, admitting that they've been had, that it's over, I think what they're doing is just keeping quiet about it. The most basic thing debunks their entire conspiracy. Thank you, Phil. See you next time. I'm UNIRock. I'm going to DLive. DLive.tv/UNIRocktv. Peace. Outie. DLive.tv/UNIRocktv for the after show. See you there.